So the distance from New York to Lisbon on the other side of the Atlantic is well over 3,000 miles. At the average walking speed for a human, you could trek there in a month and a half. That's not counting the rest stops and much-needed sleep. Buying an airline ticket or boarding a ship aren't just better options, but the only travel possibilities right now. But if this long journey on foot became possible one day, would you be up for the challenge? The most obvious obstacle is all that water in the Atlantic Ocean. It covers around a fifth of the Earth's surface. All the oceans take up around 70% of our planet. When you open the tap or buy a bottle, you are drinking a tiny percentage of potable water. 97% of Earth's water is located in oceans. It's all salt water, and it's not drinkable. Add this 2% of water trapped in glaciers and ice sheets, and you get less than 1% of water that we actually drink. When you put these percentages into numbers, you'll need a long sheet of paper to write them all down. The U.S. Geological Survey estimates that there are over 330 million cubic miles of water in the world. It's essential for sustaining all life forms, including humans. Oceans play a vital role in regulating air temperature around the globe. If they didn't have any water, the area around the equator would be scorched. This imaginary line that divides our planet in half runs through 13 countries in total, such as Brazil, Kenya, and Indonesia. The world's oceans are critical for our planet's water cycle. You know, like the one you learned about in school? It rains from the clouds and water eventually ends up in rivers that empty into the oceans. Then sunlight warms up this vast body of water, so it evaporates into the atmosphere to form new clouds. Then the cycle starts over. This process shapes the global climate. That's why, for example, the Mediterranean is so popular for the summer holidays. The region is temperate. If we take the oceans out of the equation, the water cycle stops. The area where they once sat would turn into a huge dust bowl. There would be dirt as far as the eye could see. Since there is no more evaporation, clouds won't form. Rain would become scarce. Humans would soon run out of sources of drinking water. The landscape of our planet would turn into a vast desert. Imagine a Sahara-like terrain stretching across the surface of our planet. Everything would become so dry that fires would break out easily. These are hardly the ideal conditions for a long trek between continents, but let's imagine you were able to survive all this. You start walking across the desert land that was once the Atlantic Ocean. What would that journey be like? You would encounter a landscape different from the one above the waterline. Everything below the waves is taller and deeper than the world we know. This is the land of extremes. Take, for example, the highest mountain on the planet. If you were thinking about the Himalayas and its tallest peak, Mount Everest, you are correct. Well, kind of. This mountain range is the highest when you measure it from the sea level, just above 29,000 feet in height. But when you measure the height of the mountain from its base to the peak, then the Himalayas drop to second place. The highest mountain on Earth is actually Mauna Kea in Hawaii. It's a dormant volcano. In the local language, its name translates as White Mountain. Nearly half of it lies under the waves of the Pacific Ocean. Its full height is close to a mile higher than Mount Everest, at 33,500 feet. We can't appreciate its scale right now, but if the Pacific dried up, we would be able to stand at the base of this giant. The bottom of the Atlantic hides a similar mountain range. It's the largest geological feature on the planet. We can't see it because the mid-Atlantic ridge is almost completely submerged. It rises from the ocean floor to a height half of that of Mount Kilimanjaro. The width of the massive underwater range reaches 1/10 of Earth's diameter. The only visible sections of the mid-Atlantic ridge are islands such as Iceland and the Azores. The remotest inhabited island in the world also belongs to the visible part of this geoformation. Perhaps the only thing more impressive than its size is the date of the discovery of its ridge. Scientists charted it out in the 1950s. That's pretty recent when you consider our civilization is thousands of years old. This shows how little we know about what's hiding under the surface of our oceans. UNESCO estimates that humans have explored only 5% of Earth's oceans. It seems hard to believe, but more people have been to the moon than at the bottom of the ocean. The deepest place on our planet lies in the Mariana Trench. The discovery of the Mid-Atlantic Ridge revealed the secret behind the formation of continents and oceans. When you know the truth behind their origins, you'll know what to expect on your imaginary trek across the Atlantic. The ridge sits right between North America and Europe. But you need to think of these landmasses not as continents, but as tectonic plates. These are huge chunks of Earth's outer layer. It's called a lithosphere, and is mostly comprised of rock. There are around 15 to 20 such ginormous plates on our planet. They float on a layer of partially molten rock. Well, they don't actually float, but that's the term scientists use to best describe their instability. Tectonic plates are constantly on the move. They can bump into each other. In this case, one plate goes down while the other one is lifted. This creates vast amounts of energy. On the surface, we get earthquakes and volcanoes. Tectonic forces gave our planet its familiar shape. That's how the Himalayas formed 40 to 50 million years ago. Around that time, the Indian plate shifted northward. It bumped into the southern part of the Eurasian plate. Since the two plates were composed of a similar type of rock, they each refused to go under the other. The only possible direction was up. This process is still not over. The range grows by 1/3 of an inch every year. A similar thing is happening with the Mid-Atlantic Ridge. It is widening at an annual rate of 1.5 inches. And there's an interesting side effect of this process. Do you remember the time when you were building sandcastles? In order to build the keep, you needed to dig up a lot of sand around it. As the castle grew in size, the hole around it became bigger. The same thing is happening in the Atlantic Ocean, but on a much larger scale. As the ridge is getting wider and wider, the two coasts are drifting away from each other. The North American plate and the Eurasian plate are moving apart. This means that your imaginary trip in a world without oceans might take longer. For every year you wait, you'll need to cover an extra inch. Now, that doesn't seem like much today, but give it some time, and you might not have to embark on a cross-continental journey after all. The continents will come to you. Now, evaporation is not the only way to drain an ocean. The coast on each side of an ocean might simply close in on it. This is what scientists believe will happen to the Pacific. Some 50 million years from now, give or take, you wouldn't be able to recognize the Earth's largest ocean. Experts ran a series of computer simulations to see where North and South America are headed. The answer is to the North Pole. This is where they'll merge with Asia in the distant future. The new supercontinent will completely change the shape and size of the Pacific Ocean. Geologists have a name ready for this landmass: Amasia.
There's a stretch of water that even the most experienced explorers fear. No matter what season you choose to cross it in, you risk meeting face-to-face with waves that can reach as tall as the Hollywood sign. I'm talking about the Drake Passage, the waterway connecting the Pacific Ocean to the Atlantic Ocean, stretching from Cape Horn at South America's southernmost tip to Antarctica's South Shetland Islands. It's about as wide as the distance from London to Berlin and takes up to 48 hours to cross. Some sailors compare getting on the other side to going to the moon. That's how challenging it is. Even the man who discovered it, Sir Francis Drake, never sailed these waters because they seemed too dangerous to him and opted for a calmer, although longer, Strait of Magellan. The passage took the lives of around 20,000 sailors and over 800 ships. Tourists who want to see Antarctica cross the Drake Passage on a regular basis, although it's still often called the world's most terrifying ocean crossing. The Antarctic Peninsula, where travelers go, isn't really part of Antarctica itself. It sticks out and points towards South America like two fingers almost touching it. The water gets squeezed between these two land masses, making strong ocean currents. The passage is part of the Antarctic Circumpolar Current, the largest ocean current on Earth. The water rushes through the passage at a speed between 95 and 150 million cubic meters per second, which makes it rougher. And then there are winds that usually blow from west to east and are very strong between 40 and 60 degrees latitude. That's why those areas are called the Roaring 40s, Furious 50s, and Screaming 60s. Land slows down winds, which is why storms hitting Ireland and the UK get weaker as they move east. But Drake's latitude is the only place where winds can blow all around the Earth without being stopped by land. So they keep getting faster. These strong winds turn into huge waves that can hit ships really hard, normally around 13 to 16 feet tall. They're much higher than waves in the Atlantic. Drake Passage also has underwater mountains that you can't see. The huge current squeezes through this narrow passage and causes waves to crash against these mountains underwater. These internal waves create whirls that bring cold water up from the deep ocean. So it's not just rough on the surface, the water is wild all the way down. The first sailor managed to sail around Cape Horn and through the Drake Passage in 1616. It was a Dutch navigator, Willem Schouten, in 1616. But the most famous attempt to cross it was undertaken by Sir Ernest Henry Shackleton on his ship named Endurance. He and 27 of his men set off from South Georgia, aiming to reach Vassal Bay in Antarctica. But things didn't go as planned. On January 19, 1915, their ship got stuck in the ice. And by October, it began to sink. They camped on floating ice for 2 months before sailing lifeboats to a remote, icy place called Elephant Island. Shackleton and 5 men made a risky journey to South Georgia to get help. It took them 15 days to cross Drake Passage with hurricane winds. Finally, they arrived safely and organized a rescue for the rest of their crew. Scientists found the shipwreck of Endurance only in 2022, 10,000 feet below the water. In December of 2019, 6 fearless athletes decided to cross the Drake Passage by rowing a boat for the first time in history. It took them 12 days of non-stop rowing with a 90-minute rotation of rowers. They managed to do it, and it was probably the hardest possible way to cross the passage. The athletes mentioned it was cold, wet, and dirty, and the waves hit them like walls. The weather in the Drake Passage changes a lot, but ship captains can always see it coming and change their path. They will move the departure time to have a safety margin and not to get stuck in the middle of the passage in the worst possible conditions. Sometimes, the journey will be smooth and calm, and they call it Drake Lake. Other times, people on the ship will feel rough waves, which is called Drake Shake. Some experienced captains who often cross the passage say that the Drake Lake effect happens once in every 10 crossings. And they see the Drake Shake once or twice in every 10 journeys. A schooner or a kayak will probably not survive the journey among giant waves, but modest vessels and cruise ships have sturdy hulls and advanced stabilizing mechanisms. So, the journey isn't that dangerous anymore, but still, it's quite an adventure, especially if you're seasick. If you don't feel like risking it but want to travel from the Pacific Ocean to the Atlantic Ocean by water the fast way, the Panama Canal is waiting for you. People first started thinking about making a water path across Panama in the 16th century. Back then, a Spanish explorer found out that only a thin piece of land separated the two oceans. But it seemed impossible to build it because of the mountains and thick jungle, so the idea had to wait a couple of centuries. Finally, in 1880, France, led by the man who built the Suez Canal in Egypt, tried to make the canal. But the people who started the construction soon found out it was much harder than it looked on a map. The land in Panama was one of the toughest and most dangerous places to dig a big waterway. Workers had to literally move huge mountains in a jungle full of snakes, where it was really hot and rainy. During the wet season, heavy rain turned rivers into wild rapids and soaked the workers. Sometimes, they didn't see the sun for 2 weeks, and their clothes stayed wet all the time. Big rocks were falling, and tiny mosquitoes that carried malaria made people very sick. And then, an earthquake happened on top of everything. They were losing thousands of people. That's why France decided to abandon the project after 7 years. Then, the United States bought the French assets in the Canal Zone and finished it by 1914. It cost the U.S. around $375 million. The 50-mile-long passage of water saves ships traveling between New York and San Francisco 7,872 miles. Around 14,000 ships use it every year and pay around $1.8 million in tolls. So it looks like it all paid off. Another challenging waterway in this part of the world is the Amazon River. It's around 4,300 miles long and flows through 3 countries with over 30 million people living in its basin. But there isn't a single bridge across it. The river has many marshes and soft soils, so engineers would need to build very long bridges and very deep foundations, which costs a lot of money. Building bridges over deep water is tough, but in other places in the world, engineers can use things like floating platforms to help. The river's path and water levels change a lot during the year. During the dry season from June to November, the river is usually 2 to 6 miles wide. But in the wet season from December to April, the river can become as wide as 30 miles. And the water level can rise by 50 feet. That's why they can't build floating bridges or pontoons. The riverbanks are made of soft dirt that moves and erodes with the seasons, and it makes things even harder. It would have to be an absolutely unique project to overcome all these challenges. Luckily, there's no pressing need for a bridge across the Amazon right now. The river mostly goes through areas that are sparsely populated, so there aren't so many major roads to be connected by bridges.
Do you know how many continents there are on Earth? That's an easy one, 7. But wait a second, aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist, or at least they used to. They are hiding under other land masses. Peekaboo! Researchers have recently discovered one continent just like that. It's called Greater Adria. Sound familiar? Yes, it has something to do with the Adriatic Sea. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's 8th continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint – under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low, and that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, and there would still be 7,000 feet between it and sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other, one goes down while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Yep, the coldest and one of the hottest places on Earth were once the same territory. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean. These islands are all that is left of an ancient landmass. They have a cold climate. The islands feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The Lost Continents landscape probably resembled that of New Zealand. Now, while we're in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right of the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. But there is evidence of an even greater landmass, the lost continent of Mauritia. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steps of Mauritia. They found a mineral that exists in rocks which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. The local dishes would definitely be spicy. Now, speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Sahul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side and the Greater Australia on the other. Back then, Bali stood at the southernmost tip of Asia. Biologists were among the first scientists to notice the split. Species develop differently on Sunda and Sahul. That's why Australia has unique animals, such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. Today, the two islands are separated by the Torres Strait, but it's quite shallow, less than 65 feet. It's a reminder that this was once a single landmass called Sahul. Another ocean strait that isn't too deep separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels were 300 feet lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Talk about the ultimate backpacking route. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangia was a supercontinent that included all of the continents. Its name is in Greek, and it simply means all Earth. But Pangia started to crack up. The biggest gap formed between the Americas on one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 1 inch per year. Doesn't seem much when compared to the average human lifespan, but in the end, all the continents will reconnect with each other, forming a supercontinent. And it wouldn't be the first time in Earth history that this happens. Honestly, I'm not going to wait around for that.
Scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia, hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallachia and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylasolio. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan arum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand, along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Argoland. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently they finally found its remains. Turns out, poor Argoland's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Argoland were pushed upward, grabbing the younger rocks on land. Because of this, Argoland broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now, the islands are home to unique species both on land and in the coral reefs nearby. Mauritia broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zircons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future. The world's largest fence spans over 3,100 miles from Queensland to South Australia. If stretched out, it could easily connect London to New York. And if you'd walk next to it, you'd need 6 months to complete the journey. It wasn't built to safeguard the Australian border. Why would it, since Aussies are just surrounded by water? It wasn't meant to protect some important building either. Its purpose is to keep some animal species away from each other. It was back in the late 1800s when Australians started building parts of this fence. They wanted to create a barrier separating the lively, bustling part of the country where cities like Melbourne and Sydney thrive from the harsh, dry outback. They used wooden posts dug deep into the ground, linked up with wire mesh standing about 6 feet tall. Some parts of the fence even have a second electrically charged layer. To make sure this fence did its job, they added some red and white lights to help guard things even at night. A team of over 20 people work full-time to keep things in check here. And every year, local authorities chip in around $750,000 to keep the construction in shape. Why all this trouble? The main reason was dingoes. These gingery, wolf-like creatures are Australia's largest carnivore mammals, and they're also apex predators. They were causing a lot of trouble to local farmers, especially in southern Queensland, where they often go after sheep. For the most part, the fence has been doing its job okay, but it's not foolproof. Some dingoes still manage to sneak through. Other times, wild camels end up crashing into it. That's because Australia has quite a massive camel population roaming around. But this man-made solution did more than locals expected. They thought there would just be fewer dingoes within the fence, but fewer dingoes mean more kangaroos. And more kangaroos mean more competition with the sheep for food. It's not just the bigger species feeling the squeeze. The smaller animals and the greenery also went through changes. With all this competition in a smaller space, locals noticed less diversity in the plant life and small animals. The soil became less nutritious over time, affecting plant growth. Plus, the fence acts as a roadblock for animal migration and seed dispersal. Even the sand dunes are feeling the effects, with less grass cover to hold things together. When scientists looked at kangaroos on both sides of the fence, they noticed that the young pups inside were lighter and tinier on average. The outsiders had bigger feet and heads for their age, and it wasn't because they were eating a different diet. The kangaroos that were stuck sharing the land with dingoes had to bulk up faster to survive. On the flip side, those inside the fence took it slower because they weren't under the same type of pressure. These had to compete with a lot of other creatures for food, so a bigger size wasn't a priority anymore. Researchers are still not sure if this difference is a quick fix or a long-term gene adaptation. What about domesticating dingoes? Wouldn't that help? Many think dingoes were once pets in Australia, but it's not known for sure. These days, they're pretty wild, just like wolves, hyenas, or coyotes. Most of them don't need packs to survive and are solitary hunters with sharp instincts built in. So taming them isn't going to be easy. Still, taking down the construction is not an option for now. Australians are so strict when it comes to making sure dingoes are kept away that they even put laws in place for people who mess up with the fence. Leaving a crossing gate open can put people behind bars for up to 3 months. Damaging the fence can cost people 6 months' worth of their freedom. It wasn't the first time Australians thought a fence could help with animal issues. Before they needed it for dingoes, they experienced a serious bunny invasion. Cute as they are, rabbits were damaging the land used for farming, so locals thought of a 3-part fence. The first one stretched all the way from Ravensthorpe in the south to Pardue Station on the Pilbara coast. It was over 1,100 miles long, making it the longest unbroken fence globally at the time. all these bunny problems could have been traced back to a man named Thomas Austin. Back in 1859, when he first came to the land down under, he thought it would be a good idea to release a few rabbits into the wild, thinking it would add a bit of charm to the place. But since rabbits aren't native to Australia, they didn't have any natural predators at the time. They're also pretty adaptive creatures, needing just some grass for feeding. They reproduce at astonishing speeds too. A mama rabbit can have 4 litters a year, with as many as 5 bunnies each. Pretty soon, their numbers boomed. By the late 1880s, the bunnies had caused so much damage that local authorities came up with a proposal. They'd offer the equivalent of almost $2 million today to anyone who could come up with a solution to this long-eared problem. Nobody claimed the prize, but a commission did gather a bit over a decade later and came up with the fence idea. Maintaining those fences was complicated. They had inspectors keeping an eye, with each one responsible for a stretch about 500 miles long. There were also these boundary riders patrolling smaller sections, using bikes at first, then switching to camels or using camels to haul buggies. They even tried using cars at one point, but they couldn't handle the rough terrain and constantly had punctured tires. In terms of its effectiveness, well, by 1902, rabbits were already hanging out on the wrong side of the fence. That's why, 4 years later, they put up another one. It worked for a while, so much so that the local authorities didn't bother helping out farmers past that second fence with rabbit netting loans. Those caught between the two fences, however, still had a rough time dealing with rabbit trouble. Soon enough, rabbits spread even over fence number 2, and it was clear the solution didn't work. In some areas, even while the fences were being built, those sneaky bunnies found their way past them. To this day, the rabbit population still sometimes puts the Australian officials through rough times. The dingo fence may be the longest one, but it's not the weirdest. The aquarium fence in Turkey might take that prize. This 164-foot aquarium fence was built to make sure the expensive villa's ocean view would be visible from every one of its levels. These days, it gathers a lot of tourists from all over the world, eager to see the variety of fish it contains, and even the octopuses. Putting up a see-through structure wasn't hard. The real challenge was connecting the aqua fence to the Aegean Sea through a buried pipeline stretching across 13,000 feet of land. This ensures water constantly flows, keeping the aquarium clean and the fish happy. To make sure no one damages the delicate fence or steals any of the fish or two, the owner also invested in security. He installed a network of 17 cameras equipped with facial recognition. Visitors are free to look and take pictures, but step too close and you're likely to trigger alarms. Another one of those weird fences is New Zealand's bra fence. If you ever find yourself through central Otago, you might stumble upon a fence adorned with bras of all kinds of shapes, sizes, and patterns. Its story takes us back to 1999, when people in the area found 4 bras mysteriously hanging on the fence near Cardrona Valley Road. Some were a bit surprised, but then others started adding their bras to the decor. Some more bras appeared, and it became a must-see spot for tourists. Its popularity was so high that at times it caused traffic problems in the area.
Scientists claim that Icelandia was a region between Greenland and Scandinavia that was more than 230,000 square miles, but is now underwater. The Earth was once a large pizza pie, with all the continents connected to each other millions of years ago, otherwise known as Pangia. The North Atlantic region we know today was dry land from about 335 million to 175 million years ago. For many years, scientists and geologists assumed that the North Atlantic Ocean was birthed as Pangia began to split apart roughly 200 million years ago. With volcanoes in the region where Iceland is, the country came to be just 60 million years ago as it broke off and sailed away from all the other lands. And since the Earth was like a large pizza pie, it divided like one. Many of the lands split up into many large and small pieces, creating the continents we know today. But this new theory suggests that the result of Pangia's splitting left out some land that stretched for around 200 miles. And just about 10 million years ago, that piece of land submerged in the waters on the eastern and western side, leaving the tip of the land, which is now Iceland. When plate tectonics move, they grind on each other, which gave shape to our current landscape, all thanks to the mantle. This new radical theory goes against everything written in history books and what scientists have been studying. They began shaking heads, drawing lots of skepticism and criticism. But by analyzing the ocean floor under Iceland and the Earth's crust, we can assume that this idea isn't far-fetched. The crust beneath Iceland happens to be a lot thicker than the typical ones. Oceanic crust is made up of unique melted rocks compared to the land crusts where we walk and live on, and is a lot more denser. The thinnest layer on Earth is the crust, where life takes place. It's essential for water, growing food, gathering natural resources and minerals, and breathing in oxygen. It sinks below to the bottom, but right above the Earth's mantle. It also refreshes itself, since it constantly gets recycled into the mantle and back up. This is why the rocks in the oceanic crust are around 25 miles thick, compared to just 5 miles anywhere else. This is also reasonable given that it's in a hotspot for volcanoes. Magnetic surveys of the ocean floor show layers of molten crust in stripe patterns. Also, given the fact that the Earth's magnetic field changed its polarity over millions of years, it played a role in shaping the foundation of our landscape. But there isn't any concrete evidence to prove this new theory just yet. One of the first steps is to start digging the ocean floor near Iceland. Zircon is a very sturdy mineral that can last for billions of years despite erosion in the Earth's crust. By taking samples and studying them, researchers can estimate the geological age of the continents. This will make sure the crust is oceanic, which is thicker, or continental, which is the regular crust we walk on. This isn't an overnight project and would come with a hefty cost. Another way is to do seismic surveys that can measure echoes conducted on research ships. Drilling holes miles deep in the crust can also help with the research. But this would cost more than studying the zircon minerals. Some fossilized plants unique to both Scandinavia and Greenland might prove that Icelandia was once on the surface and possibly scattered with trees. It wasn't a cold land as it is today, so it may have had forests. But scientists still haven't found fossil evidence of animals common in both lands to suggest anything. But maybe time will tell. The theory goes deeper, which suggests that there was a greater Icelandia. With Iceland, Ireland, Britain, Scandinavia, and Greenland all in one microcontinent, it could be a destination of winter enthusiasts and great for skiing. It could be possible to connect Canada to Greater Icelandia by train over the ocean, which would open up the economy even more. Iceland is around 40,000 square miles, which is already quite big. And if the Greater Icelandia was present today, then Europe would be a completely different continent. Many theories are circulating about other possible hidden microcontinents around the world. Scientists aren't certain of the possibility of Icelandia's existence, but if all the studies conducted were done correctly, then the theory could change everything we know about Iceland and the North Atlantic Ocean. And this could pave the way for other sunken microcontinents around the world. Another theory out there is that New Zealand was the tip of a lost subcontinent, even bigger than Icelandia, called Zealandia. Studies show that it's separated from the supercontinent Gondwana between 79 to 83 million years ago. Scientists claim that it's the thinnest and youngest continent discovered underwater. Craton is a core rock that acts as the main foundation for most continents. It's at least 1 billion years old, but the continental crust that makes up Zealandia is just half of that, which makes it quite young. That means some craton is missing, even though it holds some leftovers of older rocks and parts of the mantle. They're estimated to be as old as 2.7 billion years old. Scientists did some studies on the zircon crystals from New Zealand and found out that they're as old as 1.3 billion years old. The rest of the continents are more than 3 billion years old. Scientists studied the composition of the rocks in the bottom of the ocean around New Zealand. They're made up of silica and granite, which are found in continental crusts. The ocean floors mainly have magnesium and iron-rich rocks. They're also thicker and higher than regular ocean crusts around it. They conducted some studies and collected magnetic and topographic data to see the link between the Tasman and Coral Seas in the Cato Trough region. This is the narrow strip between Zealandia and Australia. Satellite data tracked tiny faults in the Earth's gravity to map out the crust of the ocean floor surrounding the area. They saw the mass that makes up Zealandia quite visible and almost the size of Australia. Even though the signs are there, this doesn't prove anything. It's possible that there are a bunch of microcontinents which all split apart when Australia broke free of Gondwana. Back then, the supercontinent was made up of South America, Antarctica, Australia, Zealandia, Arabia, and the Indian subcontinent. New Zealand is already not the biggest country out there, but if the theories are correct, then Zealandia will be 6 times its original size. Mauritius is a young island that's only a few million years old. Just 1,200 miles off the coast of Africa, it's believed that the tiny island came to life around 9 million years ago. The underwater volcanoes in the region spewed out so much lava that it formed the land today. But scientists found zircon rocks that are more than 3 billion years old. It may also be part of a continent submerged underwater called Mauritia, which is just a quarter of the size of Madagascar. The zircons they found were embedded in solid rocks and not just in the sand, which may rule out that they just washed up on shore from another continent. Some scientists are still not convinced. They suggest that discovering rocks that stand out from the other typical ones brought by an eruption could skew the scientific community to this theory. But just like how Icelandia could be part of Greater Icelandia, Mauritia was once called Rodinia, which consisted of India and Madagascar. Theories suggest that Mauritia was covered in water when India broke away from Madagascar, something like 85 million years ago.
Here on our good old planet Earth, water is literally everywhere. Not only in the oceans and seas, but also in the atmosphere, in the ground, and even in our cells. It covers as much as 71% of the surface of our planet. Looks like our planet should have been called water and not Earth. But what would happen if water and land were distributed equally? What if half of the planet became land and the other half was water? Well, let's find out. First of all, let's discuss what we mean by equally. Despite all the things mentioned earlier, there's actually not so much water on our planet. Yeah, if you collected it all in one giant drop, it'd be slightly larger than the United States in size. And all this amount of water would only be 0.02% of the total mass of Earth. So, it turns out that all these horrifying unexplored ocean depths are basically nothing. And now, just imagine if we changed the composition of our planet by leveling the volume of water and land. What would happen then? Then, we'd get a very creepy ocean planet. The planet would look like one boundless ocean. It'd be very unlikely that you'd find even a couple of small islands on it. And if you did find them, they'd probably be the tops of huge underwater mountains. This world would be practically uninhabitable. If you were on its surface, you wouldn't be able to see the sun or anything else in the sky. You wouldn't know what time of day it is or where exactly you are, all because of the incredibly thick fog and clouds. This kind of weather would be permanent on such a planet. Moreover, you wouldn't even understand where the fog ends and the water begins, all because the humidity would be that high. But could there still be life? Well, maybe inside the ocean itself? Unfortunately, this is also quite unlikely. You see, to get to the bottom of this ocean, you'd have to swim vertically down, not for several hours, but for several days. And even after such a journey, you wouldn't see the bottom yet. The ocean wouldn't be bottomless, of course, but the seabed would consist mainly of very hard, impenetrable ice. but not the kind of ice we're used to. This ice would be exotic. There are different types of it, called Ice 5, Ice 6, and so on. Usually, these types of ice aren't as cold as regular ice and may not melt even at high temperatures. And there would be almost no algae or anything like that. So fish would simply have nothing to eat. That's why, if life appeared on such a planet, it would be a miracle. This life would have to withstand a pressure of more than 20,000 Earth atmospheres. Even the most horrifying monsters from the Mariana Trench would be nothing in comparison to the creatures you'd find on this ocean planet. But could we, humans, live there? Well, theoretically, yes, but it would be extremely hard. We could create something like giant underwater stations, but we would still have thousands of problems. Where to get food and other resources, how to repair stuff, and so on. So it would be far from the best option. Okay, now we know that an ocean planet doesn't sound too endearing. What about another option? What would happen if the surface of the Earth was 50% water and 50% land? For this to happen, we'd need to reduce the current amount of water from 71 to 50%. In this case, the sea level would drop by about 2 miles, and a quarter of our planet would become dry land. Although it doesn't sound like much, the consequences would be disastrous. Right now, there are 5 interconnected oceans on Earth: Atlantic, Indian, Pacific, Southern, and Arctic. But if we lowered the sea level, all these oceans would simply disappear. They'd turn into separate closed reservoirs and seas. On the contrary, all the continents would merge into one giant landmass, almost as if we swapped the land and water. At first, it would seem pretty cool. Now, you could literally walk around the world. However, the amount of land you'd have to travel would also increase. Every continent on the planet would grow in size. All this new territory would be approximately equal to the current area of Asia, Europe, Africa, and North America combined. Well, that would be a huge mass of unused space. But what would we find on these new territories? Most of them would be pretty flat. But in places where there used to be deep oceans, you would see vast corridors and steep crevices. Now, here's another cool thing. Most of the sunken cities would return to the surface. And no, unfortunately, we wouldn't find Atlantis among them. But there would still be a lot of other cool places. For example, the ancient Roman city of Baia, which, according to legends, was basically a paradise on Earth with all its luxurious villas and gardens. Or Heraklion, the city that went under the sea thousands of years ago and was considered a myth for a long time. So yeah, we could organize tours to these ancient places. But of course, not everything would be fun and games in such a world. Due to a severe loss of water, ocean currents would be disrupted, and this would lead to very serious climate problems. The ocean absorbs the heat radiated by the sun. Thanks to the currents, this heat is distributed all over Earth, which creates a stable and pleasant climate. But if these currents were disrupted, then the temperatures on Earth would become more extreme. It would get much hotter near the equator and even colder around the North and South poles. So yeah, unfortunately, the Antarctic ice wouldn't save us. It would be quite the opposite. The regions around the North and South poles would completely dry out, basically turning into dry, cold deserts. In addition to heat, water also absorbs carbon dioxide from the air, and since the oceans wouldn't be able to absorb it, this gas would begin to accumulate in the atmosphere. This poisonous excess would cover the entire planet. The average temperatures would increase, and the whole planet would start to dry out slowly. Massive forest fires would break out, and so on. Sound familiar? Now, to make matters worse, there would be nothing to extinguish these fires, because, rains can't form from nothing. So yeah, the precipitation levels would fall, and this would lead to dangerous droughts. We'd get a bunch of new deserts on all the continents. Despite getting all those new territories, it's unlikely that we could somehow build new cities and towns there. Many of these territories would be uninhabitable, not only because many forests and plants would disappear, but also because most animals would migrate to more pleasant places. As a result, we would have great difficulty finding any food at all. So, all life on our planet, plants, animals, and people, would have to adapt to new living conditions. They would have to evolve quickly and get used to the constant shortage of water. Animals, for example, could shrink in size because of this. Many of them, due to the lack of grass and moisture, would switch to a strictly carnivorous diet. And of course, we would have to say goodbye to the huge abundance of marine life. Many fish would disappear forever. Humans, most likely, would make a big evolutionary step backward. Not only because we would lose a large number of resources and move to new territories, but also because we would also lose access to one of the most important sources of energy in the world, hydroelectric power. Without electricity, many factories would stop working. To say that this would cause a large-scale crisis for us all is sadly obvious. So, our current ratio of water and land is the best possible option. If there was too little or too much water, the consequences would be awful. That's why we need to protect the current conditions with all of our might. Surprise! There's more than 7 continents on our planet. Argoland, a hidden continent, may help us understand how our planet will look in the future. To find out how it hid from us and what secrets it holds, well, you'll just have to keep watching. Ready for a mystery? Scientists have been looking for a piece of land that's been missing for over 100 million years. Not exactly newsworthy, since people search for information about our planet's history all the time. You'd think it was probably this minuscule island somewhere in the middle of an ocean. Well, you'd be wrong, because this continent used to be as big as the entire U.S. territory. For a long time, geologists have been wondering whether a massive chunk of contemporary Australia vanished into thin air. Some believed it was simply hiding somewhere on the ocean floor. But thanks to some Dutch specialists and 7 years of investigating, we now know there are bits and pieces of this lost land mixed underneath the lush jungles of Southeast Asia. The continents we see in our geography manuals these days are like scattered pieces of a puzzle. There's even a nice experiment you can conduct to see for yourself. Find a world map online and print it out. Cut out all of the continents and play around with them for a while. You'll see they all fit together. Probably the most striking thing you'll see is how South America perfectly fits near Africa. If you close up the oceans that were formed in the last 200 million years, the continents look like they form a giant letter C. And that C is what scientists call the supercontinent Pangia. It was swimming in an ocean called Panthalassa, and the inner portion of that letter C had a smaller stretch of water called the Tethys Ocean. It is in this small ocean where things get interesting. Back in the Jurassic period, this vanished continent, which scientists started calling Argoland, vanished and left a hole in Australia, now known as the Argo-Abyssal Plain. Geologists initially believed this was all due to a process called subduction. It's when one piece of the Earth's crust dives under another and recycles it into the planet's mantle. Usually, specialists track this continental vanishing through off-scraping. That's how they figured out, for instance, that India bumped into Asia and gave us the majestic Himalayan mountains. But for Argoland, things were a bit more complicated. Bits and pieces were popping up in places like Myanmar and Indonesia, but they behaved like these time-traveling relics, looking way older than when Argoland supposedly separated from Australia. It immediately raised the question, if one continent can behave so weirdly, how many others are out there doing the same? Thankfully, scientists have now put together the entire timeline of Argoland and figured out its mystery. It didn't sink or get swallowed up. It simply transformed into an archipelago, breaking into smaller pieces, called microcontinents, and floating away from Australia. These mini-continents then took a little journey before settling down in Southeast Asian jungles. This discovery fits right into the whole Pangia puzzle. It helps us better understand how continents break up and make up, all in one discovery, revealing secrets of biodiversity and climate back from in the day. If you'd like to find out more secrets about history, civilization, or random day-to-day objects, be sure to like this video and subscribe to the channel. Like, for instance, the mystery behind this invisible species line in Indonesia. It's called the Wallace Line, named after the British explorer Alfred Russel Wallace. Over 150 years ago, Wallace was on a journey around the Malay archipelago, visiting thousands of islands. What he found was that animals on one side of this invisible line were considerably different from ones on the other side. This invisible line is like a wall between marsupials and tigers, for instance, or honey eaters and trogons. But now we know that around 35 million years ago, Australia broke up with Antarctica and collided with Asia, and this continental love triangle triggered significant changes. It didn't just change the way the land looked, it also messed with the species of animals on each side of the Wallace Line. In more recent times, a bunch of specialists published a study saying this collision and climate chaos made Asian species comfy living in the Malay archipelago. Meanwhile, the Aussie animals weren't as happy with the new environment. It was too hot and wet for some, and others just couldn't handle the tropical island lifestyle. The discovery of this continental shift towards Asia might also explain a recent finding of a human species that didn't seem to make any sense either. You see, in this hidden cave in the Philippines, archaeologists stumbled upon a new human ancestor. It seems that about 50,000 years ago, on the island of Luzon, there was this ancient human-like species. The lead researcher believed this finding was crucial for understanding human evolution in Asia, and it named this new species after the island, Homo luzonensis. Now, here's where it gets a bit confusing. The bones found by archaeologists had one small problem. They had a weird mix of traits that hadn't been seen together in any other hominid species. Smaller teeth, similar to ours, yet hands and feet that were more like our ancient humanoid ancestors. It was those throwback limbs in particular that connected this human species with the long-lost Southern Territory. That's because they have this primitive look, like these hard-to-pronounce guys, for instance. Only these two species are separated by 2 to 3 million years of time in evolution. Many have wondered, is Homo luzonensis really a new species? Not everyone is convinced. But it may also explain why living creatures are also affected by the constant shifting of the land underneath us. Now, just because they haven't changed much during our lifetime, it doesn't mean our continents will look like this forever. They evolved from this large megacontinent, and they'll most likely end up in a similar position in the future. On that note, a geologist from a European university tried to predict the future of Earth's supercontinents. As a starting point, he used an earthquake that occurred in Portugal back in 1755, when tectonic plates behaved a bit differently than they should have. After years of research, he came up with a theory in 2016. He believed that the stitches between these tectonic plates might be coming apart, setting the stage for a bigger rupture. It's like when glass cracks between two holes in a car windshield. If this happens, a subduction zone could stretch from the Mediterranean all the way up past Ireland, bringing volcanoes, earthquakes, and new mountains to these areas. If all goes according to this plan, the Atlantic Ocean will disappear, and so will the Pacific, turning into one large stretch of water. Instead of the 7 continents we know today, we'll get a new supercontinent, which he called Arica, because it would have Australia and the Americas at its heart. Now, it's not the only possible scenario, though. Novo Pangia might be another, and it's easy to foresee. The Atlantic stays open and the Pacific closes. Then there's Amasia. For this one, you'd have to imagine the Arctic Ocean closing and the Atlantic and Pacific staying open. Everything shifts to the north around the North Pole, except Antarctica. One final scenario would be called Pangia Ultima. Slow down the spreading in the Atlantic, and a new subduction plate pops up on the America's east coast. Well, either way, if all the continents collide in the future once more, some say it won't be fun to experience. It's believed that in around 250 million years, we'll feel like we're being trapped in a sweltering, soggy plastic bag. Weirdly, that bag will be the best place to live on Earth, the coastal areas. As for the inland spots, they'll be sizzling, like a desert on fire. Many of the species of animals we know today might not make it. As for us humans, we'll need to be creative if we want to withstand the heat. We should be thankful, though. These digital models are still great because we can use them to test all sorts of interesting ideas. For example, how these supercontinents would mess with tides. Taking future space travels into consideration, these models can help us understand the climates of exoplanets too. Those are located outside our solar system. I'll bet you've heard of the lost civilization of Atlantis sinking into the waters off the coast of ancient Greece. The story is supposed to be a myth, but have scientists finally found the lost city? Not sure about that, but they did find a lost continent. Wait just 1 minute. I've lost socks, keys, and even a few marbles. But how careless do you have to be to misplace an entire continent? We'll have to ask our planet about that one. Earth lost what was called Greater Adria between 100 and 120 million years ago. So, how did that happen, and where did it go? The only way to describe the process would be kind of like a snake slipping through rocks or going down into a hole. It's easier to imagine losing a continent when you think about how hard it is to find a snake that's escaped your curious stares. Most snakes don't leave trails. In fact, if you weren't around 100 million years ago to watch that snake slide beneath a boulder, and I wasn't, you'd never know it happened. Just like scientists might never have found Adria if it weren't for the snakeskin, the mountains. Let's say your fleeing snake slithers under a rock. It's long past due for a shedding, so its old skin scrapes off and bunches up right there in that tiny space between the boulder and the ground. That's what Greater Adria did. When it broke off from a humongous landmass known as Gondwana, stick around for more on that here in a few, the Greenland-sized chunk headed north. When it eventually crashed into Europe, it slipped under and caused the meeting place of the two continents to fold and scrunch up. For years and years, it just kept going, and those folds kept growing. In the end, it left behind very obvious and famous traces. You might even have gone skiing on them during a winter vacation. I'm talking about the Apennines and the Swiss Alps. Professor Douwe van Hinsbergen, the geologist who led the research team responsible for this colossal discovery in September 2019, has his own analogy. He compares this folding action to what happens when you stick your arm into a small space and your shirt sleeve can't fit through. It bunches up, and those bunches are like the mountain range. You might be wondering if other mountain ranges have similar origins. They do. Ever push sand together with your hands? Your hands work like shifting land masses, and those peaks of sand you created are a mini version of the Rockies. The snakeskin, your shirt sleeve, the sand. The point here is that mountains get left behind when massive chunks of land smash into and slip under each other. But what about the disappearing continent that leaves them? What happened to Greater Adria itself? Just as a snake burrows underground for the winter, Adria kept sliding beneath the surface. Dr. van Hinsbergen thinks she's probably nice and cozy about 900 miles under southern Europe right now. But wait a minute. Is Greater Adria still a continent if she's underwater or under land? Is a snake still a snake when it's underground? Of course it is. In fact, I know a continent that's mostly underwater yet isn't lost at all. Ever heard of Zealandia? It's also called the New Zealand continent or Tasmantis. It looks like an archipelago, which is a string of islands. But if you peek under the water, you'll see that it's really one continuous piece of submerged land with mountaintops poking out over the surface. Those peaks are the islands. Zealandia is categorized as a microcontinent, which then begs the question: what is a continent anyway? That's a matter of some debate. In fact, we Earthlings can't even agree on how many continents, not counting the lost and micro ones there are. Generally, a continent is an enormous landmass. If you're from the US, you heard that there are 7 of them: Africa, Antarctica, Asia, Australia, also called Oceania, Europe, North America, and South America. European school kids, however, combine Europe and Asia into Eurasia, so they only learn 6 continents. South Americans also recognize 6, but they keep Europe and Asia separate and combine North and South America instead. What's even stranger is that everyone seems to agree that Australia is a continent, while Greenland isn't, and has to make do with the title of World's Biggest Island. Poor Greenland. This all has something to do with the tectonic plates that lie beneath the continents, but that's a discussion best left for another video. So, where did all these continents come from in the first place? Well, if you've ever looked at a globe or a map, you probably noticed that the two great landmasses surrounding the Atlantic Ocean, North and South America on one side and Europe and Africa on the other, seem like puzzle pieces that could be pushed together to form one even more gigantic mass. You might also know that there's a name for that mass – Pangia. Scientists think Pangia, a supercontinent if there ever was one, broke apart 175 million years ago, but not into those two big left and right puzzle pieces we have today. Instead, the split probably ran horizontally, leaving a connected North America, Europe, and Asia on top, a mass called Laurasia, while South America stuck it out with Africa, Antarctica, and Australia in a mass known as Gondwana. Yes, that very one that Greater Adria would break free from later on. So, if you took all of Earth's land masses, continents, microcontinents, islands, and archipelagos, and squished them together, would you get the original blob of land known as Pangia? Nope. Not only would you be missing the parts of continents that lie underwater, like the masses connecting archipelagos, you'd also be missing all the ones lost over time. Oh yeah, there are others besides Adria. Scientists are looking for them, and they've already found some. One of those lost continents is the Rio Grande Rise. It's a stretch of underwater seamounts that's been dubbed Brazil's Atlantis. Greater Adria lay somewhere between North Africa and southern Eurasia. Hey, that's right around the Mediterranean Sea, and the Mediterranean is where Greece and Athens are. So, Greater Adria must have been Atlantis, right? Doubtful. Historians think Plato made up the story of Atlantis, but could it have really happened? You might think so if you believe the story of Greek deities punishing the civilization for starting a beef with Athens, but a more scientific theory would propose that Atlantis was simply flooded. Or perhaps it could have been one of the islands scraped off and left behind when Greater Adria dove under Europe. Disappointing as it is to say, the one thing we can't be sure of is that Adria itself wasn't Atlantis. The tectonic forces that shoved the continent under Europe did so over 100 million years ago. That's about 80 million years before any human showed up on our planet to start a conflict with Athens or anyone else. If you look at all the world's continents like broken puzzle pieces that formed a shattered Pangia, you could say that Dr. Van Hinsbergen and his team have spent the last 10 years trying to put that puzzle back together. And like actual puzzles, it's hard to do that when you're missing a bunch of pieces. I'm looking at you, Adria. But they have fancy geological equipment that tracks the magnetic record left behind in the rock's minerals. You see, every rock, stone, and mountain has a sort of imprint of the time and place it was created. It all has to do with the Earth's magnetic poles. They change every now and then in a process called geomagnetic reversal. So, in a nutshell, the specific magnetism of certain sediment and minerals works like a map and calendar. And that's how they know where Adria came from, where she ended up, and who she met along the way. By studying the magnetism of these samples, the team also found out another interesting detail. Greater Adria not only crashed into Europe, but she was also spinning on the way there. A twirling, dancing mass of land whose carefree trip northward would be cut short by an unexpected roadblock known as Europe. Hey, that would make for a great bedtime fairy tale for the kids. Now, my only remaining question is, if Greater Adria dove beneath Europe, could she rise again? It is possible. Continents keep shifting, and they remain on the move today. But they tend to go at a snail's pace. So, check back in another 100 million years, and we'll see how many continents second graders are learning about in the future. I won't be here, though. I'll probably retire.
At the end of December 2021, an underwater volcano with a rather exotic name, Hunga Tonga, woke up after several years of sleeping. It did that with so much energy and strength that people heard the eruption from over 100 miles away. Then it went back to sleep. but a couple of weeks later, it woke up again with a force 7 times greater than the first time. It broke the island above it in 2 parts. The lightning storm that started because of the eruption was the most intense in recorded history. The sound waves from the eruption traveled around the planet several times. Someone even heard a loud boom from it in Alaska. And it started the first known mega tsunami since ancient times. This tsunami took the lives of 2 people as far as Peru and caused trouble for 2 fishermen in California. But that's not all. This eruption could change the weather patterns on Earth for years. You may see the first proof in the summer of 2024, which is forecast to become much wetter than usual. Scientists believe the eruption was caused by gas building up to a critical point. Different minerals, including anhydrite quartz and sulfides, were building up for several months until they blocked the flow paths and sealed the gas within Hunga Tonga. Normally, when a volcano erupts, the fumes cause a temporary cooling effect on Earth's surface. But Hunga Tonga's eruption was different. It didn't produce much fumes, but released a massive amount of water vapor, roughly equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned huge amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its effects on our weather patterns. They can't tell exactly how long these effects might last either. This is because the only way to measure stratospheric water vapor is with satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. Experts from different countries started analyzing satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and, most importantly, what this would mean for the planet. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. In the following years, there wouldn't be enough water vapor left to enlarge this hole. It looks like Hunga Tonga will have just a minimal effect on global average temperatures. But there are some surprising, lasting regional impacts. One of the scientific models forecasts colder and wetter winters for northern Australia until about 2029. In North America, it predicts warmer winters, and Scandinavia could have even colder winters. This is just one study though, and one approach to understanding how the eruption of Hunga Tonga can change our weather. We do have at least one example from history when a volcano eruption changed the world. Over 2 centuries ago, in 1815, Mount Tambora erupted and caused the year without a summer. In the following year, the winter was unusually cold and wet weather across Europe and North America. A recent study confirms that 1816 wouldn't have been this cold without the volcanic eruption. The immediate effects of the eruption were catastrophic, with tsunamis destroying homes, claiming 10,000 lives, and 80,000 more who fell ill in the aftermath. The eruption of Mount Tambora was one of the strongest in the last 1,000 years. It had ejected an enormous amount of sulfur dioxide into the stratosphere, which quickly spread across the world. It resulted in the coldest year in at least the last 250 years. In May, frost wiped out most of the crops in New York, Massachusetts, New Hampshire, and Vermont. By June, heavy snow covered the ground in Albany, New York, and Dennisville, Maine, and New Jersey had 5 straight nights of frost. The cold continued into late summer, which should have been the harvest season. In July, lakes and rivers were still frozen as far south as northwestern Pennsylvania, and frost stayed in Virginia until late August. Temperatures would drop from above normal summer highs to near freezing within just a few hours. The weather was completely unpredictable. Prices of food skyrocketed. The cost of oats for horses, which were the main mode of transportation, also rose sharply. Some people believe this situation inspired Carl Drees to invent the bicycle in 1817 as an alternative transportation method. Tambora changed weather patterns completely for not just 1, but 3 years. The whole planet got colder, and as crops failed, probably at least 1 million people starved. Scientists don't have solid evidence of volcano eruptions that have taken more lives than Tambora. But the Krakatoa eruption in Indonesia in 1883 is far more famous than Tambora because information about it spread worldwide via telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami with waves about half as tall as the Statue of Liberty. Still, it was less powerful than Tambora's eruption. The island that once hosted Krakatoa disappeared in the eruption, but new eruptions began less than 50 years later and created the Child of Krakatau cone in the center of the caldera of the old eruption. The new volcano still comes to life from time to time. Mount Vesuvius's eruption, which took down Pompeii, is one of the most well-known volcanic disasters in history. It took around 2,000 lives, much fewer than Tambora. According to a famous Roman author of that time, the eruption lasted 18 hours. Pompeii was covered by a layer of ash and pumice that was thicker than twice an average human height. The nearby coastline also changed dramatically. In today's world, the after effects of volcanic eruptions are often more dangerous than the eruption themselves. Thanks to advances in technology, we can now predict volcanic eruptions more accurately and use safety measures like evacuations and flight cancellations. But there's still a lot of risk that changes in weather patterns and drought all over the world, especially in areas like India, East Asia, and East Africa that are affected by monsoons. Volcano eruptions can also have effects you wouldn't probably expect, like the evolution of dinosaurs. These guys were once the size of cats, waiting for their time to shine. It came around 230 million years ago. This time is known as the Carnian pluvial episode. Before it, Pangia was a dry and arid supercontinent. But then, there were 4 major volcanic events that pumped huge amounts of carbon dioxide into the atmosphere. Global temperatures and humidity spiked because of it. These massive eruptions most likely happened because of the Wrangellia Large Igneous Province eruption in what is now British Columbia and Alaska. This prolonged volcanic activity created the right conditions for dinosaurs to blossom and diversify, and also for the rise of other groups, like modern conifers, ferns, crocodiles, turtles, insects, and early mammals. With higher temperatures and more rainfall, terrestrial plants have evolved, and humidity-loving ones have become dominant. Without those changes in the world, we could have a completely different natural history. There's some solid proof that volcanic activity has really changed the weather patterns back then. Scientists have found layers in the Earth's core that show different types of carbon. It means there were 4 massive releases of carbon dioxide into the atmosphere. The data on mercury and carbon together shows that the spike in mercury levels was thanks to a major volcanic event that affected the global carbon cycle, and not just local eruptions.
Doggerland? No, it's not a country of dogs, as you probably first thought. It's a land the size of Great Britain in the north of Europe. But don't bother trying to find it on the map of the old continent. Your search will come back empty. Doggerland hasn't existed for thousands of years. But where was it exactly? And did humans live here? Scientists are doing their best to answer these questions. Let's start with the name. In the 1990s, a British archaeologist named the area Doggerland after Dogger Bank, a sandbank some 60 miles off the east coast of England. The word probably comes from Dutch. It was used for a fishing boat with 2 masts. Makes sense, since today, the North Sea is a rich fishing area. But thousands of years ago, people living here had a different diet. Some 12,000 years ago, the last major ice age was slowly reaching its end. Doggerland didn't feature seawater, but marshlands, lagoons, forests, and gently sloping hills. At that time, Britain and Ireland weren't islands. They sat deep inland. You could set off in Denmark and walk all the way to the north of Scotland. There was a system of rivers that emptied themselves in the North Sea. Back then, it was more of a channel that separated Doggerland from Norway. The rivers were different too. The Thames flowed into the Rhine. The ancient river they formed flowed into the place of today's English Channel and emptied itself into the Atlantic Ocean. Doggerland even featured a lake. There were some glaciers as well, but the land was still inhabitable. So who lived there? There were communities of hunter-gatherers from the Middle Stone Age. This was the time of human history when our ancestors mastered chipped stone tools. They used these stones with sharp edges for spears and arrowheads. This came in handy at Doggerland, which was the richest hunting area in all of Europe. It could have easily been the most populated region in the northwestern part of the continent. The hunters' prey likely consisted of reindeer, mammoths, oxen, wild pigs, brown bears, wolves, and many other species. In short, nobody went hungry here. Meat wasn't the only thing on the menu. Ancient residents of Doggerland collected hazelnuts and berries. They lived in wooden huts. They built them close to rivers, and they even constructed their settlements on hills. Remember Dogger Bank? It now sits underwater, but it used to be a mountainous region. Doggerland must have been prime real estate in prehistoric times. Its total surface area was over 18,000 miles, but things were about to go under, literally. The last ice age was ending. All the water trapped in glaciers and ice sheets started to melt. You experience this process firsthand every time you order a cold drink. Even if you drink it bottoms up, after a while, the glass is full again. Why? Because the ice cubes have melted. Think of Doggerland as that glass. The sea levels started rising quickly. Every century, the sea flooded from 3 to 6 feet of dry land. Just imagine what this would mean today. Miami's elevation is just over 6 feet. The city would be flooded in less than 100 years. But there was one event that speeded things up. The Storegga Slides were a series of submarine landslides in the Norwegian Sea thousands of years ago. And what happens when huge chunks of Earth shift suddenly underwater? Gigantic waves. You probably know what a tsunami is. Doggerland was likely pounded by several of them. They were so powerful that researchers believe they washed away Great Britain's land bridge to the rest of the continent. All that was left of Doggerland was an island the size of Wales. Scientists estimate that the waves of this ancient tsunami were at least 40 feet high. Some 6,000 years ago, Doggerlanders were on the move. They were migrating to higher grounds, England and the Netherlands in their case. The ironic part is that when we literally translate the name of the country of Netherlands into English, we get lower lands. But thousands of years ago, this was higher ground for hunter-gatherers escaping the flood. Once it was all over, the continent of Europe got the shape we easily recognize today. But Doggerland was nowhere to be seen. It's been sitting under the waves of the North Sea for 8,200 years. Does the idea of Doggerland remind you of a more famous case of a submerged land? The lost city of Atlantis comes straight to mind. But there is an important difference. Atlantis is only a legend. Everything we know about it comes from the writings of the Greek philosopher Plato. Scientists have been searching for Atlantis for a long time. And, up to this day, they can't even agree where exactly it was. Theories range from the Mediterranean to even Antarctica. Doggerland is not a myth. Everything science knows about this lost land comes from hard evidence. In 1931, a fishing boat was doing its thing off the coast of Norfolk in England. At the time, the crew would drag a net along the sea floor, sweeping everything in its path. And they caught something more than fish. It was peat, like the stuff we find in Alaska and in Ireland. But what was it doing at the bottom of the North Sea? It didn't belong there, because seawater destroys peat. There was only one possible explanation. The area must have been dry land at some point in history. The final proof was that the peat contained a harpoon spear point, a sure sign of human activity. The idea wasn't new, though. Since the Middle Ages, There has been talk of submerged land with underwater forests. In 1913, a British geologist came forward with the idea of an undersea world in this part of Europe. Scientific evidence kept piling up. Local fishermen started pulling out human-made tools and animal bones. Researchers dated them to be around 9,000 years old. But the deep, murky waters of the North Sea made it impossible to send down divers. One archaeologist noted that they knew more about the surface of the moon than what lay at the bottom of this relatively shallow sea. The discovery of oil in the area in the 1960s was a real game changer. Companies from the industry provided seismic survey data to scientists. This helped them piece together the full image of what Doggerland used to look like. Computer models soon produced images of river valleys, coastlines, freshwater lakes, and hills. There are even footprints of nomadic tribes preserved on the sea floor. Today, marine biologists are using magnetic fields to map out this lost underwater world. But Doggerland isn't the only place on Earth that went under the waves. Beringia is another lost world of global importance. This used to be a land bridge between Asia and North America. It got its name from the Bering Strait. It is 53 miles wide at its narrowest point. But until the end of the last ice age, this was dry land that our human ancestors called home. Genetic evidence shows that Native Americans lived in Beringia for some 15,000 years. If you want to imagine what this land looked like, think of present-day Arctic Alaska. It was a shrub tundra. There were also small willows and birches. Sorry, no woolly mammoths. Large grazing animals simply wouldn't have had enough food in Beringia, though there were probably elk and bighorn sheep in the area. But the Ice Age wouldn't last forever. Like in Doggerland, sea levels started to rise. This happened some 13,000 years ago. It wasn't all bad news, though. Scientific evidence suggests that around this time, people started moving south. They left the slowly sinking Beringia and crossed over into Alaska. From there, they populated both Americas. These were the ancestors of Native American tribes.
You find yourself in Africa, land of unique wildlife, home to a great variety of cultures and languages, and, first and foremost, host to the world's largest hot desert, the Sahara. It's daytime, and you are thirsty for some water and shade. You've been walking for days, trying to find one of those precious-looking oases. You feel you're near, but the horizon just keeps stretching and stretching. Your mind is tired, and your body is feeling all the heat. It's like you've eaten a full plate of hot pepper and then some more, judging by how much you're sweating. And when I say hot, think 100 degrees Fahrenheit hot, on average. No wonder this is happening. After all, you find yourself in the world's biggest hot desert. Now, I say hot desert since the biggest deserted landscapes are actually the cold ones, located in Antarctica and the Arctic. Icy Antarctica's frozen desert is more or less the size of 1 million LAXs. Yep, the Los Angeles International Airport. The Arctic Desert is just a bit smaller than that. Now, in case you don't know, the Sahara Desert is located in northern Africa, stretching from the Atlantic Ocean all the way over to the Red Sea. It occupies an area large enough to place approximately 100,000 Disney World theme parks side by side. According to scientists, its boundaries are expanding. Deserts usually form in the subtropics because of what's called Hadley circulation. The air rises at the equator and descends into the subtropics. This circulation of air has a drying effect, which helps the formation of desert landscapes. Since the 1920s, the Sahara is considered to have expanded by over 10%. How is this happening? Well, let's start from the beginning. You probably know the Sahara Desert as one of the most inhospitable places on Earth today. Just FYI, for a place to be considered a desert, it has to receive less than 4 inches of rain per year. Due to the very small precipitation index, deserts are usually dry and arid places. There is little humidity in the air, and daytime temperatures can go as high as 130 degrees Fahrenheit. Usually, there isn't that much animal and plant life because of the lack of water. But in the Sahara's case, it wasn't always like that. It may be difficult to imagine northern Africa without the tons of sand it has today. But about 20,000 years ago, the Sahara was actually one big oasis. Recent discoveries show clear evidence of what the scientists now call the Green Sahara. In the mid-1800s, a German explorer crossing the Sahara encountered some paintings and engravings that nomad artists had left behind. What he saw in those paintings looked nothing like his actual surroundings. Instead of an arid landscape with only camels and desert vegetation, the rock paintings depicted jungle animals like giraffes and hippos. There were even images of livestock and grazing animals such as cattle and sheep, something that seems impossible for modern-day Sahara. Artists usually draw what they see around them, so this finding really intrigued the German explorer. The drawings were so detailed that the artists must have had close contact with those animals. You can find this rock art spread out in the northern part of the African continent, from western Sahara to Saudi Arabia. Geologists soon took a keen interest in this and found the first clues to what this could mean. They have been able to confirm that, in fact, northern Africa was once much wetter. They found evidence from nearby deep-sea sediment off the coast of Mauritania. Sampled cores of underwater sand and mud, known as Saharan dust flux, showed geologists that, indeed, a green Sahara was possible. The more dust is blowing off of the desert and into the bottom of the ocean, the drier the climate in the region. The sediment cores show that there was much less dust, only half as much, coming off northern Africa during the humid period. This period has to do with Earth's natural cycles. Normally, the Earth rotates at a tilt of 23.5 degrees, but this angle is not consistent and changes over time. Earth's tilt is responsible for the amount of sunlight each hemisphere receives. It affects several ecosystem functions on the planet. During the time of the Green Sahara, the Earth received between 4 and 8% more sunlight than it does today. So, when the Earth tilted about 20,000 years ago, the northern hemisphere received more direct sunlight, which affected humidity levels in the region. As the northern hemisphere got warmer, this affected monsoon activity, more specifically, the West African monsoon. Monsoons are wind systems that affect a region's rainfall index and humidity levels. As a part of the globe gets warmer, it allows for more air to rise. It combines with the wind to draw moisture up into the atmosphere. Little by little, northern Africa also became wetter. The increased moisture made the Sahara so wet that there were actual bodies of water in the region. As vegetation grew, the plants held onto moisture better than bare sand could. There is evidence of natural basins throughout the Sahara and lakes so big they would fit all of the U.S.'s Great Lakes inside of them. Archaeologists uncovered evidence of vibrant societies in what are now arid areas. It looks like ancient cultures were able to take full advantage of the African humid period. According to researchers, the human population peaked across the Sahara about 9,000 years ago. There are traces of fireplaces, hunting tools, fishhooks, and even mounds of fish bones. Records show that there have been over 230 green periods over the span of 8 million years. Solar radiation is always changing due to natural orbital cycles. That's why Earth will most certainly see another green Sahara moment. It might be thousands of years from now, but it will happen. The same way the Sahara turns green, it turns yellow again. Let's put it like that. All it takes is a significant axial tilt and a few years of readjusting. However, another phenomenon is calling the attention of scientists now. Recent studies by the National Science Foundation from the University of Maryland show the Sahara has expanded 10% over the past 90 years. This phenomenon is called desertification, which literally means fertile land turning into desert land. The Sahara Desert is now advancing into the semi-arid region of Sahel. In 1950, this region was home to 31 million people. Today, its population is over 100 million people. This rapid population growth has largely contributed to the Sahara's expansion. Farmers that were once nomads began settling down. Land usage grew more intense, aiding in weakening the soil. The demand for food has caused an overcropping of the land, so even more of it is turning into the desert now. The study also shows that natural climate cycles can affect rainfall in the Sahara and the Sahel. Scientists affirm that all deserts fluctuate, not only the Sahara. A desert's boundary may expand in the dry winter and contract during the wetter summer. South of the Sahara lies the Chad Basin. It is a natural body of water that now serves as an indicator of the Sahara's expansion. The Chad Basin is located in the region where the Sahara is advancing southward. An atmospheric and ocean expert from the University of Maryland explains that rainfall has reduced greatly in the entire region. Due to reduced rainfalls, there is less water across the entire basin, and even Chad Lake is drying out. Just like the Sahara, the Atacama Desert in Chile, deemed the world's driest, is also expanding. It is located north of the city of Santiago, and its southern border is expanding toward the Chilean capital. Because the climate is getting drier and drier here, the city of Santiago risks turning into an arid or semi-arid region itself. The once fertile valleys of local rivers that lived on agriculture and livestock for many generations are losing their revenues as Chilean land is turning into a desert. Since 2010, Santiago has received only a third of its annual rainfall. Outside of the city, farmers are digging holes in search of blue gold, or simply put, water. The situation here is very similar to that of Sahel. So tell me this. Were you as surprised as I was to find out what has been happening in the Sahara region? Feel free to share in the comments below.
You pack up your bags and head to the most remote island in the world. You can't stop jumping for joy, knowing you'll have an island all to yourself. Destination: Bouvet, the loneliest place on Earth. There's no airport on the island, so all those who have a fear of flying can just relax. This lonely island is located in the Atlantic Ocean between South Africa and Antarctica and is frozen all over. It's uninhabited, so there aren't any humans for at least 1,400 miles from here. And even though you won't find any coffee shops or theaters, the island hosts a decent number of animals, like seals, birds, and penguins. And no, there aren't any forests or jungles, but you can find some moss and lichen. Right now, you're on a ship wearing a thick jacket and cupping hot tea in your hands. It's been days since you left the coast of South Africa. Finally, you see the island out in the distance. Many frozen cliffs surround it, so it's really difficult to scale it. Maybe a helicopter could do the trick. The place was pretty popular back in the day and was named 3 times since its discovery. But not even the smallest piece of land goes homeless for long. So Norway decided to keep it. They even gave it its own internet domain, .bv, but no one has created any websites under it yet. As of now, the place is mainly used by scientists to study whale migration. Tristan da Cunha is a small volcanic island in the Atlantic. It's quite lonely too, but this time you can actually find some settlers. Its closest neighbors are Buenos Aires in Argentina and Cape Town in South Africa, both of which are more than 1,000 miles away. Just like Bouvet, this place doesn't have an airport. You could catch a ship from Cape Town instead for a 7-day voyage costing you between $800 to $1,500. Be prepared for a long visit. These ships don't come and go every day. You may find yourself booking a place for an entire month before going back home. There's no mistaking this place with its giant 6,700-foot volcanic cone, which actually erupted in the 1960s. Luckily, they were able to evacuate everyone to a neighboring island in time. This little piece of land is home to no more than 280 people and has its own decent economy to sustain itself. About 1,300 miles south is St. Helena, a more vibrant and hip island because, guess what? It has an airport. Planes fly all the way from South Africa once a week. But there's a trick. Pilots have to be specially trained to land in the mountaintop airport. The country is smaller than Rhode Island, the smallest state in the U.S., but what it lacks in real estate, it makes up for in its rich history. Napoleon spent his final years on the island, and it's also home to the oldest tortoise in the world. Population here doesn't exceed 5,000 people who love to enjoy the beach and the amazing highland scenery. In 1790, a group of British and Tahitian sailors reached a chain of islands in the South Pacific in the middle of nowhere. Seeing as they were stuck and loving the isolation, they decided to create a settlement on one of them. Later, these land spots would be called Pitcairn Islands, and still, only one would be left inhabited. The population? 50 people. You can find a mix of cultures between British, Polynesian, and other Pacific Islanders thriving and living life to the fullest. And why wouldn't they? All 4 islands have incredible subtropical climates and rich volcanic soil for crops and vegetation. In 2016, it was labeled the world's 2nd largest marine protected area. Be prepared for a long sea voyage if you plan on paying a little visit. You can catch a ride on a supply ship that hosts 12 passengers each trip. 2,500 miles off Africa, in the southern part of the Indian Ocean, you'll find Amsterdam Island. No, the capital of the Netherlands didn't pack up and sail away. This remote island is home to an extinct volcano that rises to about 3,000 feet, and the place itself is only as big as a mall. There are no permanent residents, but it hosts scientists and a research facility, around 30 people. All the way north is the Norwegian archipelago of Svalbard. Seems calm and peaceful, with people enjoying their days. Except, wait, get back inside. This place is known as Polar Bear Island, where the bear population outnumbers the human one. You may arrive by plane or ship, but either way, you'd be getting a breathtaking view of snowy mountains and cute, colorful buildings. Despite the curious bears, people have been able to maintain a stable life there, and the island is actually home to many nationalities from over 50 different countries. Svalbard welcomes anyone to stay and live without a visa, as long as they have some place to stay and a job to make a living. It's located roughly 500 miles north of Norway in the Arctic Ocean. But where isn't the only tough question. It's when you go, too. If you're not a nocturnal type, then consider going there in the bright half of the year, where you could experience sunlight nearly all day, every day. Because during the other half of the year, there's total darkness. But you'll get to witness some beautiful northern lights right above you for quite a while. Svalbard is considered the most northern settlement in the world, and actually has the most northern university as well. Because of the permafrost, life isn't easy here, which means they get most of their stuff on ships from abroad. But that didn't stop the dwellers from having the global seed vault to host almost 1 million seeds from around the world as a backup, in case crops can't grow anymore. Off the coast of Chile is the easternmost presence of Polynesian culture. 2,300 miles west of South America and 1,200 miles away from Pitcairn Islands, the most famous island inhabitants are known around the world for their huge heads. Yeah, those heads. More than 600 are scattered across Easter Island, but archaeologists dug deeper and discovered that their bodies are buried beneath the ground. The island is also known as Rapa Nui, or the Great Rapa. It doesn't have white sandy beaches, but the dry sunny spots and amazing ashen cliffs were formed by the lava from volcanoes. North Sentinel Island is a beautiful paradise with just one problem. No one is allowed to enter it. There's a native tribe living there, untouched by any outside civilization, and everyone decided to keep it that way. Over the last 200 years, several dozen people were able to get a hands-on experience with the islanders, but let's just say it didn't end well. It's even completely off any shipping route to avoid contact. 10 years ago, a study indicated there could be between 80 to 150 people on North Sentinel, but there really is no way of telling, since that number could be as low as 15, or even exceeding 500 people. They're so isolated that the people in the neighboring open islands don't understand the Sentinelese language. Some researchers were able to pick up little snippets of their lifestyle. They live in huts with slanted roofs and fire pits facing each other. They have a healthy seafood diet and live on fruits that grow on the island. There isn't any harbor, but soft sandy beaches as far as the eye can see. Too bad we can't get in. Tuvalu is a young island country in the west central Pacific, made up of 9 small coral islands placed in a chain-like formation. The main island is only a few miles long and is so narrow at times, you can ride a motorbike with ocean waves striking on either side. It's pretty rare to see cars around as well. The locals are mainly of Polynesian descent and speak Tuvaluan, but you can easily get around with English. The country has an airport, but when there are no flights, the entire landing strip turns into a football field and playground for everyone to enjoy. Despite not having many tourists, Tuvalu is known around the world for its own web domain, .tv, which it leased to a Canadian television company. Makes sense to me.
A
colossal iceberg, more giant than a city, broke away from Antarctica in mid-2021. It's so big that it's 40 times bigger than Paris and 73 times the size of Manhattan. Imagine that you come out of your small holiday shack on the coast of South Africa, near the town of Port Elizabeth. You have a cup of tea in your hand as you've just woken up. You stand near the edge of your lookout, the vast Indian Ocean before you. Something catches your eye. To the right, there is something so monumental, you can't comprehend it. It's a giant slab of ice, 300 feet high, and stretching away many miles, as far as the eye can see. It rolls slowly, but relentlessly on, heading out into the deep sea. If it goes far enough, it could reach the western coast of Australia. Playing in front of it are a pod of dolphins, like they sometimes do off the bow of a ship. Yet they're just specks compared to the mammoth size. You're so shocked that you drop your cup. Your eyes are as big as saucers. It's like something out of a science fiction movie. Are you dreaming? Are you seeing things? Nope. It's A76. It's real, and it's currently on the move. What could happen to it is anyone's guess. Well, scientists have a few theories, but let's get a grasp of its size first. The iceberg is 110 miles long and 16 miles wide. It's basically the shape of a gigantic finger. If you were standing at the coast of Dover, looking across the English Channel toward France, the iceberg would be almost as wide. The channel is 21 miles across at its narrowest. That means approximately 2/3 of that distance would be filled with the iceberg. That's if it were drifting finger pointing down, so to speak. If it were facing the other way, it could still enter the English Channel, but as it got closer to the narrowest points, it would smash into the coasts of both England and France. It would go up over land. It would slide over the green fields of England, the white ice bold against the rich green. It would cruise past the vineyards of France. It was temporarily lowering the temperature of everything around it. Those grapes would be like jelly crystals. It would skim right over highways, cars stopping to observe this colossal thing, like a visitor from another galaxy. You could pluck chunks off it for your drink as it sailed past. Failing that, you could scale it and go ice climbing, right on the outskirts of London. It would certainly be handy in the summer. But let's get back to what actually happened, and what scientists think will happen to it. As of the beginning of 2022, A76 is the world's most giant floating iceberg. It was calved from the Filchner Ronne ice shelf in Antarctica in the middle of May 2021. Ice calving, also known as glacier calving, is the breaking up of ice chunks from the edge of a glacier. It then pulls away from the ice mass into a separate entity. If you were nearby, you would hear a lot of cracking and a massive booming sound. Blocks of ice up to 200 feet would break free and crash into the water. It would cause huge waves. Not even adventurous surfers would want to tackle those breakers. Ice calving is a natural event. The area where A76 broke off has seen little change in recent decades. There have been even larger chunks of ice than A76, but this one is currently the largest in the world. Scientists at the British Antarctic Survey spotted it. There are satellite images of it breaking free, as captured by the European Space Agency's Sentinel-1A satellite. The size at the calving was an estimated 1,670 square miles. Right now, it's in the Weddell Sea around Antarctica. The Weddell Sea is part of the Southern Ocean. It was named after the Scottish sailor James Weddell, who entered the area in 1823. Scientists have deemed the Weddell Sea to have the clearest water of any sea. Imagine peering down into its depths from a boat. What a fantastic view it must be. The area is full of whales and seals. As you look down, you may see killer whales, humpback whales, minke whales, leopard seals, and crab-eater seals. And if you look towards land, you'll likely see a colony of Adelie penguins. They're the dominant penguin species in this area because they adapt to the harsh environment. In fact, this is the only location in the world they live. What an incredible array of wildlife to observe, all from the comfort of the ship's deck, while you drink another cup of hot tea. It gets pretty cold in these parts. To get an idea of what could happen to A76, scientists refer to other data, such as the even more enormous iceberg called A68. It was calved from the ice shelf known as Larsen C off Antarctica in 2017. While it may be exciting, though a little daunting, to think of it also sailing up the English Channel, A68 floated out to warmer seas and, by early 2021, had all but dissipated. That was a relatively quick demise. Some icebergs have been observed floating around for up to 18 years. Suppose they remain in the relatively cold waters. It all depends on where A76 decides to go. Satellites have helped scientists keep track of these monstrous movements, whereas they would go unnoticed in the past. That's how they know that by day 148, this iceberg had split into 3 fragments, imaginatively titled A76A, A76B, and A76C. The numbers might be boring, but they're based on the Antarctic quadrant in which they were first sighted. If these enormous chunks do break up entirely, it will not add to rising sea levels because it was already part of the floating ice shelf. Imagine these ice chunks in your glass. They already take up a certain amount of space. They will simply change form into water. Icebergs like this one are different from glaciers or ice sheets found on land. Those are the things that help to raise sea levels when they break off and melt. For example, if the whole of Antarctica's ice sheet were to melt, it could raise sea levels by nearly 190 feet. If you think A76 is enormous, and it clearly is, there was another that makes it look small in comparison. On record, the largest iceberg was sighted in November of 1956, 150 miles west of Scott Island in the South Pacific Ocean. Ironically, it was seen by a ship known as the USS Glacier. It was sized over 12,000 square miles. This iceberg was larger than the country of Belgium. What may happen to the chunks of A76 will depend on a few factors. Ocean currents can make a significant impact, and wind direction and speed can too. They may move closer to coastlines, where they can freeze into pack ice. They can also drift into shallow waters and hit the seabed, called seabed gouging. The deepest part of the iceberg can act like the keel of a boat. It digs into the ocean floor, but the sheer size of the iceberg keeps it moving. Soon it's tearing up the floor, creating a long, narrow furrow or a gouge. Fish would scatter, the earth would shake, the noise would be tremendous. It's actually quite common in offshore environments near where ice is found. You would not want to be scuba diving nearby when one of these rips through. However, it would make for a spectacular sight. Generally, icebergs deteriorate through melting and fracturing, which, as you can imagine, changes the mass and the surface area. Combined with wind and ocean currents, it can make iceberg modeling difficult. As for A76, we'll just have to wait and see. Before we go, let's return to our imaginary voyage down the English Channel. The island of ice, 73 times the size of Manhattan, with its gigantic frosty finger pointed down toward the Celtic Sea, rolling steadily onwards, unable to be stopped. Hundreds of thousands of people have flocked to the coasts of both England and France to watch this extraordinary spectacle as it cruises by. On top of the ice, there are thousands of penguins playing happily. They almost look to be waving back to the abundance of sightseers who cheer them on their way, the children jumping with joy at the most spectacular sight they've ever witnessed.
Wow, this port is so buzzing. Thousands of people come here every day to work, cargoes come and go, fishers are weighing their catches for the day, and even posh cruise ships pop in here to show this idyllic place to all the people on vacay. The ocean shore is fantastic. People walk along the beach eating ice cream or building sandcastles. Oh, and by the way, right now we're standing where the Sahara Desert used to be. Normally, our lifetime is too short to see any major changes. We don't notice mountains rise or the way rivers change their course. Entire valleys may be sinking, but it usually takes too long for them to sink entirely. Still, a group of scientists recently noticed there's a new ocean being formed really fast, and we can even witness it appear. Look here! It's the Afar Triangle. There's the Horn of Africa Peninsula not far away. It's the exact site where the sixth ocean is being born at the moment. Wherever you are, you're basically standing or sitting on a tectonic plate. You're just sitting on a couch watching this video? Cool! Your couch is standing on the floor, your floor makes part of your house is standing on the ground, and if you take a deeper look, it all stands on one of 15 principal tectonic plates. Together, these chunks are referred to as lithosphere, It's like a nice apple pie. The crust is the lithosphere, and the fragile apple filling is everything that's on the planet's surface. If the crust cracks, the filling leaks out. And this is what any earthquake is like. A tectonic plate, aka the crust, moves. The filling, also known as houses and people, is disturbed. Africa is made up of two plates, the Nubian and the Somali ones. Yeah, that's a large pie. And it seems like these two plates are constantly separating. It leads to an oceanic spreading ridge. It looks like the African continent is literally unzipping a part of it at this moment. A 345 square mile chunk of the Sahara Desert just split, so the magma rose. It triggered a series of earthquakes across Ethiopia, Eritrea, and Djibouti. And it's not just some minor earthquake. There are lots of fumes rising from those fissures, and it smells like sulfur. Phew! The eruptions slowly push the old lava sediments away, which is followed by creation of the new seafloor. The crack is filled with magma, and when it cools, it forms the new oceanic floor. If this process doesn't stop, the Red Sea will finally flood the area, forming the Sixth Ocean, and Africa will be split into two parts. So we'll basically have two Africas. But wait. Neither you nor your grandchildren are going to see that Sixth Ocean. You'll only have 5 of them throughout your life. Same with our future generations. Same old Pacific, Atlantic, Indian, Arctic, and the Southern Oceans. Before the oceanic floor gets solid, and before the Red Sea actually starts flowing in there, many thousands, if not millions of years must pass. The continents move as fast as your nails grow. And imagine that the longest nail ever seen in history was the thumbnail of an Indian man reaching almost 6.5 feet before he cut his nails. It took him almost 60 years to grow it. Now think how far the continents will have to move by the time you celebrate your 100th birthday. Spoiler, it's not going to be very far. But anyway, you can witness some minor changes that take place even now. All those cracks that may not seem that significant so far make all the landscape in the Afar region look really unique. There's a couple more reasons for this uniqueness. Meet Erta Ale in Ethiopia, the volcano famous for its world's longest-lasting lava lake. It's located in the Afar Depression, also known as the Afar Triangle. By the way, depression refers to the sunken area. There's nothing sad about it. It's not the only volcano in this area. Eritrea, known as the Nabro volcano. It's never erupted, yet the lava in this area is pretty active. More volcanoes are to come because of the tectonic plate movements. They pull away from each other, and the Earth's crust gets thinner. The weaker the area is, the more volcanoes there are. Okay, the plates are separating, and it's kind of inevitable. It's just the question of time. This process is also called the Afar plume. We'll get more volcanoes, it's inevitable either. But how does it happen? Remember that apple pie? Yes, it was delicious. Well, things are actually much more complicated. The outer layer we walk on is relatively delicate and is made up of multiple broken pieces. It's like the eggshell or a lattice top on a pie. Let's take a deeper look at all the ingredients of this pie. If you cut a slice, you'll see it's made up of many parts, and there's something called the asthenosphere under the lithosphere. It's part of the Earth's mantle. Yeah, complicated. So the asthenosphere gets heated from within, and it rises, just like the dough when you put it in the oven. Remember those cracks on the surface of a freshly baked loaf of bread? Man, I'm getting hungry. Anyway, this is basically what happens to the Afar Triangle, and those cracks make this area split, creating those famous rifts and valleys that will possibly become so large and will probably get flooded so that the world's sixth ocean will appear there soon. Or not. Nobody's sure about it. Okay, but since the tectonic plates and, which is logical, all the continents are always on the move, we'll probably have more continents in the future. The answer is yes and no. If a part of Africa does split, we'll get one more continent, which is going to be even smaller than Australia. But there's one more possible way of how things will go. Chances are, in the next 250 million years, in the distant 250 million years, there will be no more transatlantic flights. And a walking trip from Japan to Chile will be possible too. Way too long, but possible. It's all happening now, and the first results will be noticeable in some 50 million years from today. I won't be around then. Australia will move towards Southeast Asia, and it's going to fit in just perfectly. And Africa will be pushed to Southern Europe. Still, these transformations will take a really long time. People and continents have something in common. Remember that continents move as fast as our hair and nails grow, just about 1.2 inches a month. Some of them move even 5 times faster though, but even this speed is too slow for 4,500 miles distance between Africa and Europe. One theory tells us the things we've already seen before. Well, you didn't see that with your own eyes, neither did any of your ancestors who came to America across the Atlantic hundreds of years ago. The fact is, all the continents were once one landmass known as the Pangia supercontinent. Even though it formed over 300 million years ago and split about 180 million years ago, give or take, it might come back together. So kangaroos can easily migrate from Australia to the UK if they feel like it, but the latter might be accidentally crashed while all the continents merge together. The Americas would collide, Antarctica would drift to them, and it all will merge with the already collided Africa-Eurasia. In this scenario, one large ocean and one large continent will appear, namely Novo Pangia. Another possible scenario claims the continents might merge into the uniform landmass or form a circle with a large sea inside and the super Pacific Ocean outside. This continent is referred to as Pangaea Ultima. The third theory might be already coming to life. The Pacific and the Atlantic Oceans might just cease to exist, forming the new ocean basin. Eurasia will be split to form a new ocean, and all the continents will migrate to merge into the supercontinent Orica. And the fourth and last theory claims that the Pacific and the Atlantic Oceans will remain almost unchanged, and all the continents but Antarctica will merge into one, leaving poor Antarctica even more isolated and abandoned than it is now. Nah, don't feel bad. Since all the continents keep drifting northwards even now, it's quite probable that almost all of them will meet up somewhere at the North Pole.
Scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia, hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallacea and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylacoleo. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan arum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand, along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Argoland. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently they finally found its remains. Turns out, poor Argoland's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Argoland were pushed upward, grabbing the younger rocks on land. Because of this, Argoland broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now the islands are home to unique species both on land and in the coral reefs nearby. Mauritia broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zircons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future. The world's largest fence spans over 3,100 miles from Queensland to South Australia. If stretched out, it could easily connect London to New York. And if you'd walk next to it, you'd need 6 months to complete the journey. It wasn't built to safeguard the Australian border. Why would it, since Aussies are just surrounded by water? It wasn't meant to protect some important building either. Its purpose is to keep some animal species away from each other. It was back in the late 1800s when Australians started building parts of this fence. They wanted to create a barrier separating the lively, bustling part of the country where cities like Melbourne and Sydney thrive from the harsh, dry outback. They used wooden posts dug deep into the ground, linked up with wire mesh standing about 6 feet tall. Some parts of the fence even have a second electrically charged layer. To make sure this fence did its job, they added some red and white lights to help guard things even at night. A team of over 20 people work full-time to keep things in check here. And every year, local authorities chip in around $750,000 to keep the construction in shape. Why all this trouble? The main reason was dingoes. These gingery, wolf-like creatures are Australia's largest carnivore mammals, and they're also apex predators. They were causing a lot of trouble to local farmers, especially in southern Queensland, where they often go after sheep. For the most part, the fence has been doing its job okay, but it's not foolproof. Some dingoes still manage to sneak through. Other times, wild camels end up crashing into it. That's because Australia has quite a massive camel population roaming around. But this man-made solution did more than locals expected. They thought there would just be fewer dingoes within the fence, but fewer dingoes mean more kangaroos. And more kangaroos mean more competition with the sheep for food. It's not just the bigger species feeling the squeeze. The smaller animals and the greenery also went through changes. With all this competition in a smaller space, locals noticed less diversity in the plant life and small animals. The soil became less nutritious over time, affecting plant growth. Plus, the fence acts as a roadblock for animal migration and seed dispersal. Even the sand dunes are feeling the effects, with less grass cover to hold things together. When scientists looked at kangaroos on both sides of the fence, they noticed that the young pups inside were lighter and tinier on average. The outsiders had bigger feet and heads for their age, and it wasn't because they were eating a different diet. The kangaroos that were stuck sharing the land with dingoes had to bulk up faster to survive. On the flip side, those inside the fence took it slower because they weren't under the same type of pressure. These had to compete with a lot of other creatures for food, so a bigger size wasn't a priority anymore. Researchers are still not sure if this difference is a quick fix or a long-term gene adaptation. What about domesticating dingoes? Wouldn't that help? Many think dingoes were once pets in Australia, but it's not known for sure. These days, they're pretty wild, just like wolves, hyenas, or coyotes. Most of them don't need packs to survive and are solitary hunters with sharp instincts built in. So taming them isn't going to be easy. Still, taking down the construction is not an option for now. Australians are so strict when it comes to making sure dingoes are kept away that they even put laws in place for people who mess up with the fence. Leaving a crossing gate open can put people behind bars for up to 3 months. Damaging the fence can cost people 6 months' worth of their freedom. It wasn't the first time Australians thought a fence could help with animal issues. Before they needed it for dingoes, they experienced a serious bunny invasion. Cute as they are, rabbits were damaging the land used for farming, so locals thought of a 3-part fence. The first one stretched all the way from Ravensthorpe in the south to Pardue Station on the Pilbara coast. It was over 1,100 miles long, making it the longest unbroken fence globally at the time. All these bunny problems could have been traced back to a man named Thomas Austin. Back in 1859, when he first came to the land down under, he thought it would be a good idea to release a few rabbits into the wild, thinking it would add a bit of charm to the place. But since rabbits aren't native to Australia, they didn't have any natural predators at the time. They're also pretty adaptive creatures, needing just some grass for feeding. They reproduce at astonishing speeds too. A mama rabbit can have 4 litters a year, with as many as 5 bunnies each. Pretty soon, their numbers boomed. By the late 1880s, the bunnies had caused so much damage that local authorities came up with a proposal. They'd offer the equivalent of almost $2 million today to anyone who could come up with a solution to this long-eared problem. Nobody claimed the prize, but a commission did gather a bit over a decade later and came up with the fence idea. Maintaining those fences was complicated. They had inspectors keeping an eye, with each one responsible for a stretch about 500 miles long. There were also these boundary riders patrolling smaller sections, using bikes at first, then switching to camels or using camels to haul buggies. They even tried using cars at one point, but they couldn't handle the rough terrain and constantly had punctured tires. In terms of its effectiveness, well, by 1902, rabbits were already hanging out on the wrong side of the fence. That's why, 4 years later, they put up another one. It worked for a while, so much so that the local authorities didn't bother helping out farmers past that second fence with rabbit netting loans. Those caught between the two fences, however, still had a rough time dealing with rabbit trouble. Soon enough, rabbits spread even over fence number 2, and it was clear the solution didn't work. In some areas, even while the fences were being built, those sneaky bunnies found their way past them. To this day, the rabbit population still sometimes puts the Australian officials through rough times. The dingo fence may be the longest one, but it's not the weirdest. The aquarium fence in Turkey might take that prize. This 164-foot aquarium fence was built to make sure the expensive villa's ocean view would be visible from every one of its levels. These days, it gathers a lot of tourists from all over the world, eager to see the variety of fish it contains, and even the octopuses. Putting up a see-through structure wasn't hard. The real challenge was connecting the aqua fence to the Aegean Sea through a buried pipeline stretching across 13,000 feet of land. This ensures water constantly flows, keeping the aquarium clean and the fish happy. To make sure no one damages the delicate fence or steals any of the fish or two, the owner also invested in security. He installed a network of 17 cameras equipped with facial recognition. Visitors are free to look and take pictures, but step too close and you're likely to trigger alarms. Another one of those weird fences is New Zealand's bra fence. If you ever find yourself through central Otago, you might stumble upon a fence adorned with bras of all kinds of shapes, sizes, and patterns. Its story takes us back to 1999, when people in the area found 4 bras mysteriously hanging on the fence near Cardrona Valley Road. Some were a bit surprised, but then others started adding their bras to the decor. Some more bras appeared and it became a must-see spot for tourists. Its popularity was so high that at times it caused traffic problems in the area.
If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these 2 being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable, as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger.
The concept of oil on troubled waters may seem like a strange expression, but its meaning of calming a tense situation is well understood. The origins of this phrase, though, have a much more literal explanation. It's true that even the roughest waves can be subdued by simple oil. Just like you dress your salad with oil to make it nicer, you can dress the sea to make it calmer. At the end of the 19th century, captains from various ships shared their experiences of using oil to calm rough waves in letters to the New York Times. One of those captains, Olsen of the Norwegian bark Wilhelmine, detailed what he did to save his crew and ship during violent storms. Despite the challenges they faced, the oil trick proved to be a game changer, drying up the weather side of the deck and helping them navigate through heavy gales. His words hinted at a secret power hidden within these simple bags made of sailcloth filled with irregular animal oil. He used it several times, and each time, the technique worked like a charm. One time, his crew encountered heavy gales on their voyage to Belfast. They were causing quite a stir, but they managed to stay ahead of the game by deploying these bags made of sailcloth filled with animal oil. As soon as they released the bag from the cathead, the weather side of the deck dried up in no time, even as the seas continued to wash over it. It was pretty neat to see it working its magic without even needing to check if the bag was empty, as it was a real lifesaver. Their vessel was still a little shaky and taking on water on the lee side, but this little trick really helped them out. Captain Jenkins from the British steamer Francisco used a similar method to calm the seas during their voyage from Hull, England to Boston. They ran into some strong westerly gales, causing really big waves. They didn't want to head any further north, so they decided to stop the engines and chill for a bit. They stuffed some oakum into the pipes of the closets and filled them with oil, and it worked like magic. The sea calmed down along the side of the ship, the big waves disappeared, and they stayed nice and dry. In total, 12 masters shared their success stories of using oil against rough waves, with only one reporting that it didn't work as expected. The use of storm oil, as sailors called it, was a tried and true method of preserving crew, cargo, and livestock from the harsh sea conditions. The toughest thing some of them experienced was just a little spray. Their methods were a tad different, but all of them used oil. But what made this storm oil so effective? First off, let's clarify something. Storm oil is not your average supermarket olive oil. To be truly effective, storm oil must be made of that thick, next to water insoluble consistency. Technically, it acts like a surfactant. This practice is very old and has been used for many centuries. Since ancient times, people have poured oil to calm ocean waves. It was poured onto the ocean surface to reduce wave intensity, making it easier for sea rescuers and navigation. This spilled oil accumulates on the surface and creates a concentration gradient that leads to extra dissipation and damping as waves move. In the past, steamships and lifeboats from various countries were required to carry storm oil as this practice continued until the late 20th century. It was included in the United States Maritime Service Training Manual as essential equipment for lifeboats, and British vessels were mandated to have it until 1998. Often, vegetable oil or fish oil was used as a cost-effective option. While those options were commonly used as storm oil substitutes, the thick consistency was the key to the oil's effectiveness. Storm oil has a dampening effect on water, absorbing some energy from the waves. It quickly forms a thin layer over a large area of the water surface, preventing wind from creating waves easily. The use of oil to calm ocean waves dates back to ancient times, with Aristotle and Pliny the Elder discussing its effects. Benjamin Franklin famously studied the calming properties of oil on waves during his trips to England in the 18th century. Communication between Franklin, William Brownrigg, and Sir John Pringle led to further exploration of this phenomenon. Agnes Pockels also made significant contributions to the study of storm oils through her experiments in Germany. She suggested that the calming effect of oil on water involved more than just reducing surface tension. Oil is definitely a game changer when it comes to calming rough seas. But it's not just any oil that does the trick. You gotta use the right kind of oil and apply it the right way. Forget engine oil and other petroleum products, they won't do much. Fish oils are where it's at, especially the thick ones. The problem is, modern ships and boats don't really carry fish oils, so folks end up using engine oils and bunker oils instead. Not surprising that they don't see the calming effects they were hoping for. Back in the day, the Coast Guard used to carry a little tank of oil for rescue missions in choppy waters, but they stopped that practice ages ago. You can't just pour the oil on the water. You gotta let it leak out gradually, drop by drop. The best way is to hang a bag of cod liver oil or something like that over the side of the boat. The oil seeps out through the bag onto the water surface and smooths out the waves. Not only does the oil calm things down, but it also stops the wind from messing with the surface. Just a bit of the right oil, like a gallon or so, can flatten out a huge area around the boat. Believe it or not, tossing oil into the sea used to be allowed. Steamships and lifeboats were actually required to have equipment to slowly release oil during storms. The lifeboats on the Titanic fell under British law from 1894, which said they had to carry oil for bad weather. Now for the science part, as oil decreases water's surface tension, preventing those pesky waves from breaking. It's like adding an invisible layer over the water that makes it super smooth. So, when you pour some oil into water, the molecules don't clump up as they spread out to form a super thin layer. These oil molecules kind of do a somersault, standing on their heads and aligning with the water molecules like magnets. This creates a film on the water surface that is just one molecule thick. You can actually figure out the size of a single oil molecule by trying this out. For instance, one tester used a spoon that was under half an inch high, and the oil spot it spread out on the water was massive. If you do the math, you'll see that one molecule is incredibly tiny. Usually, wind creates waves by moving the surface of the water, but a layer of oil molecules acts as a barrier, stopping the wind from making waves and just pushing the oil around instead. This pretty cool trick has been used by all sorts of people throughout history for different reasons. I've already mentioned that Benjamin Franklin studied this phenomenon a lot, but he also liked to prank people by using this science. He would claim he could calm a choppy lake with just the touch of his cane. Turns out, he had a little vial of oil in the bottom of his cane that he could tap out onto the water surface. It made him look like some sort of magician or water-bending master. By the way, the science behind this trick is still used today. By putting a thin film of oil or smaller molecules like magnesium fluoride on glass, you can create invisible glass that reduces glare and reflection. This type of glass is used in smartphones, tablets, laptops, and glasses. If you've ever driven over the Rocky Mountains, you've probably seen road signs for the Continental Divide, the backbone of North America. All watersheds to the west of it run into the Pacific Ocean, and everything on its eastern slope goes straight into the Atlantic. There's just one creek in Wyoming that couldn't choose one side and drains into both oceans at the same time. Two Ocean Creek begins its journey high up in the Teton Range. The snow-capped peaks provide the perfect backdrop as the creek starts its descent, winding its way through alpine meadows and dense forests. As the creek continues its course, it gets to the Two Ocean Pass. This is the geographical crossroads where the creek splits into two branches, the Atlantic Creek and Pacific Creek. The Pacific Creek goes westward and becomes part of the larger Snake River watershed, bringing its waters to the Snake River, which eventually merges with the Columbia River and, finally, reaches the Pacific Ocean. The Atlantic Creek heads eastward and flows into the Yellowstone, Missouri, and Mississippi rivers, and eventually empties into the Gulf of Mexico. If you connect the two creeks' watersheds on a map, you'll get a single blue line between Oregon and Louisiana. Explorers struggling to find the Northwest Passage between the two oceans never knew they could have used the creek. They would just have to use really tiny boats. Some scientists believe that cutthroat trout had better luck in that way. They managed to migrate from the Snake River to Yellowstone River, most likely using the Two-Ocean Creek. Technically, fish can travel over 6,000 miles to cover the whole distance from sea to shining sea in fresh water. The creek could be just perfect for that journey. There are hiking trails in Grand Teton National Park that lead to Two-Ocean Pass. If you feel adventurous enough, you can stand at the literal crossroads of the continent and see the beginning of two aquatic journeys. Lonar Lake in India popped up literally out of nowhere around 52,000 years ago. Newer data says it could be much older, probably over 500,000 years. At first, scientists were sure that the lake was in an ancient crater of a long-extinct volcano. But then, geologists made a detailed analysis of the soil and water and found out that Lonar Lake has a space origin. The minerals found in its soil are similar to those found in moon rocks brought to Earth during the Apollo program. The lake is an impact crater left by a huge meteorite, which was almost 6 times heavier than the Empire State Building. The impact was so strong that the volcanic rock melted and turned into glass. In 2020, the lake, which was already unusual enough, suddenly turned pink. It wasn't a part of an early Barbie movie marketing campaign. The detailed analysis showed that the water contained an increased level of unique microbes. They accumulate on the surface and emit some pink pigment. After a while, the microbes settled to the bottom and the lake became transparent again. Flamingos that got their food from the lake also got to taste some of the microbes and became an even brighter shade of pink than usual. One of the most famous sights of Yellowstone National Park is the Grand Prismatic Spring. It's one of the largest springs in the world, and it's inspired people who have seen it since at least the 19th century. Back then, a group of trappers mentioned an indigo blue lake boiling like a huge cauldron. Decades later, expeditions came to the spring to study it better and explain its unusual appearance. But because the spring at its widest point is longer than an American football field, they had to build a special vessel and travel far from the shore. The scientists traveling in the boat never wore life vests. They knew those would be useless if the boat tipped over. The water in the middle of the spring is of near boiling temperature, and those vibrant colors are the result of extreme organisms living in the hot water. The temperature changes as you travel away from the center. Different species that don't mind the heat have settled in different parts of the pool, giving it its famous diverse pigments. Back in the early 20th century, someone got the interesting idea to try to irrigate a part of Nevada's Black Rock Desert. They drilled a well and found lots of water, but it was near boiling temperature. The water was clearly not good for agriculture, so the human-made geyser was left abandoned. Over the decades, it slowly turned into an impressive cone of calcium carbonate deposits. Then, in 1964, a geothermal energy company drilled another well close to the first one. The water they had found was of the same temperature. This time, it wasn't hot enough for their needs to produce energy, so they decided to cap the well and leave. But water managed to get up and out, and it completely dried up the first geyser. The second one, which got the name Fly Geyser, is still flowing burning hot water rich in minerals. The cone is multicolored and looks like it's not from this planet, thanks to the algae living in it, which love the heat. Every summer, Caño Cristales in Colombia turns into a liquid rainbow, or the River of Five Colors. At this time, and until the end of fall, the conditions are just right for the riverbed to turn bright red, yellow, green, blue, and black. We owe this beauty to certain aquatic plants growing in the river, a special type of riverweed. During the wet season, the river moves fast and the sun cannot get to these plants. During the dry season, there isn't enough water to feed them, so the time in between the seasons has the perfect conditions for this colorful show. It doesn't happen anywhere else in the world. At some point, the number of tourists who wanted to see it became so huge that scientists got concerned it could be bad for this hotspot of biodiversity. The area is home to rare species of animals, birds, and plants. Now, there are ecotourism trails and strict opening hours. In August 2014, a man in Tunisia was going back home from the north after doing his business. It was a hot summer evening and he was dreaming about water when suddenly, it popped up right in front of him. There was a whole lake in the middle of the desert, and the man was pretty sure it hadn't been there several days before. The new body of water got the nickname Mysterious Lake and actually became a great mystery. Hundreds of people came here to swim in the clear, cool water. The lake became a popular place, but a few days later, the water turned dark green. The locals didn't care about this and continued to bathe in the lake. But when scientists and geologists arrived at the place, they announced that the water was dangerous to swim in. The lake was stagnating. It didn't refresh itself from underground streams, and the rains didn't feed it either. That's why the water became moldy and dirty. The lake contained algae and a lot of harmful bacteria dangerous to the human body. Scientists also found out that the land in this region had phosphate deposits. This substance can decay. But even that didn't stop people from bathing in the lake in the middle of the desert. How it got there remains a mystery. Some experts think that heavy rains have filled a hole in the ground with water. Another, more popular theory says that an earthquake had formed the lake. The seismic activity must have torn the Earth's crust above the water table, and then underground springs had filled the crevice. So, in theory, the lake could drain back out one day, just as suddenly as it had appeared.
Our planet has 5 oceans: the Pacific, Atlantic, Indian, Southern, and Arctic. Not counting Billy Ocean. But it seems there's a 6th one out there too. It's just that you can't see it. Scientists have found evidence of large amounts of water hidden in the transition zone. That's the boundary layer that separates the upper and lower mantle of our planet. That boundary goes hundreds of miles deep down below the surface. Natural diamonds usually form in the mantle, but at depths of up to 155 miles. Some of them are very rare. They may come from deeper depths. That was the case with this fascinating diamond that formed 410 miles below the surface. The gem was big enough for scientists to study it and determine what it was made of. They were surprised when the composition of this very rare diamond showed that it was formed in pretty watery conditions. Because of that, such a diamond wouldn't be worth much in jewelry stores, but it was priceless in the lab. So, could this mean there's an ocean under the surface of our planet? It would definitely get us closer to the idea Jules Verne had about this whole magical secret world inside Earth, including the ocean. But that's not exactly the case. The water is there, true, but it's not like you can enjoy the view watching waves splashing around like on the surface of our planet. The water is actually stored within the minerals. That's why this area is so wet. Let's now move to Africa to keep up with the story, or to be more specific, to a spot called the Afar region. It's part of Ethiopia and a place where 3 tectonic plates meet. Tectonic plates are large pieces of our planet's crust that slowly move. These movements cause earthquakes and produce volcanoes, mountains, deep underwater valleys we call trenches, and so on. And the Afar Valley is where the Arabian, Somali, and Nubian plates meet. Together, they form an intersection in the shape of a Y. Why? Let me tell you. These plates are moving all the time. The Somali plate is moving southeast toward the Australian and Indian plates. The Arabian plate is moving north, getting closer to the Eurasian plate. At some point, it will close the Persian Gulf. This movement of plates has created something we call the Great Rift Valley, considering there are, all these cool rifts. The Aden Ridge to the east, the Red Sea Rift to the west, the Oculus Rift and the East African Rift to the south. But the East African Rift is something we want to focus on, because this one could be the key to this potential 6th ocean, but this time on the surface. A continental rift is a spot where 2 tectonic plates that form a single continent start to separate. Here it's the Somali and Nubian plates. Together, they're parts that make up Africa. If they keep moving in separate directions, this currently continental rift may become what we call an oceanic spreading ridge. In other words, when the plates are far enough apart from each other, there will be an enormous crack between them. This way, magma will freely flow up from beneath them. It'll be cool and eventually start creating a new ocean floor. Africa will be split into two parts, and there will be a new ocean flowing between what will turn into two mini-continents. Nope, it's not time to get your swim trunks and sunscreen yet. Even if the Somali and Arabian plates do move far enough to form an oceanic spreading ridge, it'll take millions of years before this happens. So I guess it's more interesting to stick to exploring this sixth ocean below the Earth's surface for now. The idea of subsurface oceans goes beyond the borders of our planet. It's possible many moons and planets out there have them too. Our home planet is the only one we know about with consistent bodies of liquid water on the surface, true. In our solar system, we circle around the Sun in something called the habitable zone. The temperature and atmospheric pressure within this zone allow water to remain in liquid form all the time. But a couple of moons in our solar system could also contain significant amounts of water under their surface. Enceladus, one of Saturn's moons, is the first one. Enceladus is a small frozen ball 7 times smaller in diameter than our moon, but it's the 6th biggest moon of Saturn. Nearly a decade ago, a spacecraft found evidence that there was a large ocean under its surface. It found and sampled water from the eruptions that resembled geysers. A geyser is a rare type of hot spring that erupts and sends jets of steam and water into the air. You know, like Old Faithful in Yellowstone? Well, this water was erupting through fissures in the ice at the south pole of the moon. That means there might be a liquid ocean under the thick layers of ice. The ocean there is almost nothing like ours. The ocean on Earth is relatively shallow, on average 2.2 miles deep, and it covers 3/4 of our planet's surface. It gets colder the closer you come to the seafloor, and is warmer if you stay close to the surface because of the sun's rays. But the subsurface ocean on Enceladus is at least 18 miles deep. It's cooler at the top because that part is near the ice shell, and warmer at the bottom because of the heat coming from the moon's core. But both our ocean and the ocean on Enceladus are salty. Enceladus is one of the few places in our solar system that has liquid water, which makes it an interesting spot to search for signs of life. Another one is Europa, one of Jupiter's moons. Scientists think similar eruptions of water could be happening there. Knowing there are such geysers there tells us these moons have their own source of energy. Maybe the energy that makes the water erupt comes from gravity or radiation. The same energy could keep a large body of liquid water under the ice. It could even support some forms of life. There are thousands of planets beyond our solar system that orbit other stars. Some are even in the habitable zone. Over 1/4 of the ones that we know about could have liquid water, but the majority of them probably have oceans under their surface, like Enceladus and Europa. Pluto might be on this list too, since it's possible it hides a liquid ocean under its thick frozen shell. This subsurface ocean likely formed long after the dwarf planet did, after the heat coming from radioactive elements in Pluto's core melted some of its ice. There's also something called water worlds. Those are moons or planets with global oceans that are more common than we thought. I mean, some call Earth a water world too. 71% of its surface is water after all. And when you look at our home planet from space, you mostly get those blue marble pictures. When exploring other planets, especially those outside of our solar system, researchers often go with a policy of follow the water. After all, water is the main element we know that's necessary for supporting life. And when there's a water world that's close to its parent star, scientists assume it must have formed way farther and then moved closer once its orbit shrank. The composition of the planet was set when it was in a colder orbit, or, in other words, when it made a wider circle around its star. We call the process of orbital shrinking a migration. And if water worlds are really that common, it can be proof that migration really happens. Exoplanets are all those planets that orbit around other stars, not our Sun. Some exoplanets may have oceans that are way deeper than any of those in our solar system, hundreds or even thousands of miles deep. Our Mariana Trench is scary, and it's not even 7 miles deep. And those exoplanet oceans are, wow, almost bottomless.
So many asteroids pass through our solar system, and we don't even know about it. Those are rocky pieces of material left over from the time when our solar system was forming, about 4.6 billion years ago. They move around the sun, but not in the way planets do. We're talking about true rebels that prefer to follow some pretty strange paths. Plus, they spin in different ways as they travel between planets and other space objects. And the majority of them come from the main asteroid belt that's located between Jupiter and Mars. Most stay there. But Jupiter has quite a strong gravity, so it can push some of those flying rocks in different directions, and towards us too. They're sometimes round, and sometimes they have odd shapes, with pits and holes from all that crashing into other space rocks. As we currently know, there are more than 1 million of them in the main asteroid belt, and that's all good until some of them move in our direction. NASA keeps an eye on them, so we know everything's fine, at least for now. But that wasn't always the case with our beloved home planet. If Earth could talk, it would probably share so many crazy asteroid stories. We're talking about those space rocks that left impact craters we call domes. They have a specific shape with a raised center, similar to when you throw a pebble in a pond and see some water splashing upward. But we'll never be able to learn about many others. I know this raised center sounds like something you're supposed to see right away, especially if an asteroid that once slammed into the surface was big. But we're talking about millions and millions of years of erosion, so wind, water, and even gravity do what they do best and erase traces. They wear down impact domes, and some sites even end up hidden under layers of rock and dirt, or they disappear forever because Earth's tectonic plates keep moving around. Check out the Moon. It's experienced many collisions too, but over there, there's no ocean or tectonic plates moving around, or even wind to slowly, through millions of years, erase craters from its face. Basically, its entire history is written on its surface. But Earth has its own forces that can erase such places as the Vedafort impact structure and the Chicxulub crater. You know, the famous one that wiped out the dinosaurs? Luckily, scientists have new methods to find ancient craters. They often focus on the mess impacts made, which means the materials they threw around. And the Australian continent is especially interesting since we're talking about a playground for asteroid hits. By that, I mean ancient supercontinent Gondwana that dominated the South hundreds of millions of years ago. Experts know about 38 impacts, plus they speculate about 43 more. Some structures are relatively small, while others are big and completely hidden. And recently, a scientist named Tony Yates has discovered strange underground magnetic patterns in New South Wales, Australia. Yay! New clues of a giant asteroid impact! And when I say giant, I really mean it. It's a structure 323 miles in diameter. This might be the largest impact site ever found. This spot is called the Deniliquin structure. Its magnetic patterns show characteristic ripples around the center, like when a rock hits the water. There are also fractures that go outward from the center. And it seems rocks from inside Earth ended up pushed into these fractures. That's a typical story for big asteroid impacts. This structure was probably located in eastern Gondwana hundreds of millions of years ago, way before it split into several continents, including Australia. At the moment, all we know about this crater is what we see on the surface. To find more information about this collision and get some proof, we'll have to drill into the ground. An asteroid this big is definitely not a joke. It could have caused a massive ice age and maybe even wiped out around 85% of species, even more than the asteroid that ended dinosaurs. In 4.5 billion years, which is how long our planet has existed, it's been punched by hundreds of big asteroids. But that doesn't mean every space rock that enters our atmosphere really makes it all the way to the ground. Most of those that manage to pass the atmosphere are relatively small, for instance, 3 feet across. That's good for us because any space rock that's less than 82 feet in diameter most likely won't make it past our planet's atmosphere. Since these space rocks come towards us very fast, they heat up the gases in the atmosphere, which burns them away. By the way, once cosmic intruders enter our atmosphere, they turn into meteors. And in most cases, they don't cause much damage, if any, as they fall down. But we used to have way larger things flying around and crashing into Earth. At least 190 of them have left scars you can still see today. One of the really big ones is in South Africa. It's 99 miles wide. It's actually the largest. At least that's what scientists think at the moment because they still need to check as many details as possible about this new crater in Australia. This one in South Africa formed about 2 billion years ago, and an asteroid that created it was probably larger than the one that had wiped dinosaurs away. And when an asteroid is bigger than 0.6 miles, it can have really big effects across the world. This impact was so strong that it could have caused fires everywhere and thrown lots of dust into the air. And when you have so much dust in the atmosphere, the climate on the planet can change for months or even years. Then we also have the most popular asteroid that made a giant hole we today call the Chicxulub crater. You know the story. It crashed into our planet 66 million years ago when dinosaurs were wandering around, catching food, falling in love. Basically, just doing their thing. The crash itself didn't erase them right away. It threw a lot of debris into space, and when it fell back to Earth, fires and flames were everywhere. The hit also produced a big cloud of dust that covered the planet for years. This cloud blocked the sunlight, which harmed plants and entire food chains. Even those dinosaurs that survived the crash and such difficult conditions had a hard time finding food, so they didn't make it. At least they left us many fossils and turned into the inspiration for movies and stories. A long time ago in Canada, something big crashed into our planet and left a big hole we today know as the Sudbury Basin. People used to think it was an asteroid, but now some experts think it might have been a giant comet made up of a mix of ice and rocks. The hole is almost gone now because of weather conditions though. But people still get to mine iron and nickel there, and at the same time find the leftovers of whatever space object fell there. If you move deep in southern India, you'll find a big hole called Lonar Crater. Locals stumbled upon it 200 years ago and believed it might be from a volcano. But now we know it's a trace from a meteor that crashed into the ground about 35 to 50,000 years ago. What's so special about this crater is that it's the only one known to have formed in a type of rock called basalt. Around the crater, there are hills covered in trees, and animals like peafowls and gazelles live there. Birds also like to visit the lake near the crater during the winter. And the lake itself is quite interesting too. It can turn pink because of all those tiny organisms that live there. But this color change doesn't last long.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.